I'm going to share my screen now. So once you are seeing my screen, please let me know. Okay, beautiful. I think finally I've gotten a way to see both my screen and the Google Meet. Oh, awesome. All right. So sorry for the interruption yesterday. All right. Uh, we will not have something like that today. Today should be flawless. So who can remind us, where did we stop yesterday? Hmm? We have a lot to cover. We have part of yesterday's class and then today's class. So let's move as quick as we can. So where did we stop yesterday? I'm thinking we stopped at this place, if I'm not mistaken, digital signatures. I think we talked about this, how public private key pairs work, right? Okay, so everybody is quiet, no problem. So digital signatures and how they work. So this is a continuation of yesterday's class, all right? So we have digital signatures is a way, is somebody, okay, sorry. Digital signature is a way to prove a message comes from a specific sender and hasn't been altered. An example is signing a blockchain transaction to approve a payment. So now, I think yesterday I asked a question, right? And then somebody was trying to paint it in the light of a stamp on a document. You know, a stamp mostly shows that a document is official. Now, official in such a way, it shows that the document is coming from either an organization or a body. So it shows the authenticity of a document. So that's what the role of digital signatures too. That's like the role digital signature plays, right? So you see, we talked about where you have your original document and then you hash the original document. And why are you hashing it? You say you hash it so as to avoid anything that have to do with the information being tampered with by a third party or any other person. So by hashing it, you are making it tamper proof, right? Now, by the time we hash it, we say hash function is a function that takes in any length of text or file, right? And then gives you a specific length as output. So we hash it. I hope this screen is big enough. Let me see. Okay, sorry. I don't think I can make it bigger than what it is already. Okay, I can. Uh, okay, let's just manage. All right. So by the time you hash it, now next is that you encrypt it. Is it encrypt hash with your private key? Now that private key, you that you are sending the message, you encrypt it with your own private key, but you are attaching the public key of the person you are sending it to. All right. Remember, we talked about that. Now, of course, your hash, just like I said, hash is to make it tamper proof. Already, this has explained a question I asked yesterday. That's why we should go and research whether cryptography is the same with encryption. All right. So now we now have an encrypted hash. After this encrypted hash, now, of course, you combine it at this stage, you add the person's public key. All right. Now, once you do all of this, what it gives you is that it gives you a signed document. So are we seeing the process of the digital signature? You take the original document you want to send, you hash it, right? Pass it through a hash function to make it tamper proof so that nobody can go and change information that is there since you are making it public. Next, you encrypt it with your private key. It becomes an encrypted hash. Because it's not the information the original document that you actually encrypt. Is the hash of the original document that you encrypt. Then next, you combine it with your public key. Upon combining it with your public key, you have a signed document. So let's look at the process, how it works. So first, user create a transaction and hashes it, right? Then next, user signs the hash with their private key. Are you seeing? So signature or signing is being done with private key. That's what I was talking about for those that probably have done airdrops. I know a lot of us have done Telegram airdrops. Even me, I've done Telegram airdrops. You know, plenty people, we like free money. All right. You find out that if you are if you want to connect to your wallet, there's this notification that normally pops up, right? Where you need to accept or read. I'm pretty sure that 90% of us don't ever used to read what is there. We just say, make this wallet connect, sharp, sharp. This airdrop, make it enter. We could use and see fraud. So I know many of you that used to check what is there. You just accept, boom. So what is actually happening is that is a notification that is notifying you to actually sign, because it can't go ahead to connect your wallet without you signing. And by you initiating that, pressing accept or pressing yes, what is happening behind the scene is that the wallet automatically takes your private key and run the signature to be sure that you are actually the owner. You trying to connect that wallet, you are really the owner of that wallet. So the signature and transactions are sent to the network. All right. Other users verify the signature using the sender's public key. So let's see now how a public key verifies a digital signature. You know, here we talked about the process of signing, how you sign a transaction and send it, because once you sign a transaction and everything, you have to send it to the network. That's the blockchain. That's what they call the network in this case, or on chain. You send it to the blockchain, be it Bitcoin, Ethereum, or Sion, or whatsoever. So now let's now look at how will they now be able to use your public key to verify, because once you send a transaction, the transaction will not just go and land on the blockchain. There are people that will have to verify whether truly that signed transaction you sent, whether it's truly your own or not. They have to verify it. And how would they verify it? They always verify it using your public key. You know, I talked about that your public key is a key that anybody can have access to. It's out there in the open. All right. So let's see. Now, we are using Ethereum as an example. All right. Say every Ethereum transaction includes a digital signature. So it means so far you are running a transaction on Ethereum or any other blockchain. In that transaction, there will always be a digital signature attached to it. And why is that digital signature there? That digital signature is to prove the sender authorized the transaction, is to prove that you authorize that transaction. It's just like if I'm going to give you a check to go to the bank and get money. Of course, I have to sign the check. Do you get it? Yes, the amount will be there and everything, but for you to be able to take that check to the bank and get that money, I have to sign it. That signature now is like I'm approving you that okay, yes, I'm the one that. So once you take that check to the bank and they check and they see my signature, they'll the next is to verify my signature. Once they verify and they find out that it's true, the person that have access, the owner of this account is actually the person that signs this check. Next is that they will now give you the money. All right. So that is actually what is happening here. Someone sent a transaction from Ethereum blockchain, and then he attached a signature to it to show that that transaction, he's the one that authorized it. All right. So let's look at the verification process. Now, one, senders initiates the transaction. Now, of course, initiating the transaction, he uses his wallet or software, because your wallet is your software. I'm not talking about the wallet you used to put money, I mean your normal wallet, Trust wallet, Brave, CMC Brave, sorry, MetaMask and the rest. All right. So hashes the transaction details. The sender's private key is used to sign this hash data. The signed transaction is broadcast to the Ethereum network. So are you seeing it? This first process is this process here we looked at. That's the number one here. So next, now see the second one, the next step, When the transaction is received by Ethereum nodes, I think you guys have done notes last week, so I will not dwell on that. They verify the signature using the sender's public key. Now, those people running node, there are also people that verify transaction. They help in verifying transactions in the Ethereum ecosystem. And other blockchain also have their own nodes. All right. So now they use that person's public key, the sender's public key, to verify the signature. Now, how do they do that? These are the processes involved. First, they extract the transaction hash. Of course, we talked about the transaction hash. It says unique. That's one property of a hash function. Very little or no collision. So it means every transaction hash is unique. Secondly, Ethereum uses elliptical curve digital signature algorithm. You can go and do more research on this. ECDSA, very, very important when it comes to blockchain. All right. To recover the sender's public key. So from this transaction hash now, right, they are going to use this algorithm to recover the sender's public key. All right. Now, from the signature and transaction hash. So they are recovering this from the signature and the transaction hash. Now, I want to ask a question, and I need two people quickly. No, we don't have time today. If you remember, we say once you hash an information, you can't unhash it again. It simply means you can't get what that information, what is inside that place again. You have hashed it, you have hashed it. Now, I want to ask a question. Now, if that is how hashing is, how comes you are able to get the public key from the signature and transaction hash? Because that's what they say there. Look at, they say they use this algorithm to recover the sender's public key from the signature and transaction hash. So how possible is that? So quickly, I need two people. Let me see if we are really following the class.
I don't understand you.
You don't understand. Is it the question you don't understand, or you don't understand how comes you're able to get public key from signature and transaction hash?
I understand the question, but I don't understand the process of getting the public key.
Okay.
So, can you hear me?
Yes, I can hear you. Go on.
So I think every unique hash is tied to a unique public key, which is an address.
Okay. I love this.
And
Go on.
let me suggest something.
Okay,
I'm
go on.
thinking like that public key address. I'm thinking
Yes.
maybe it's followed an encryption process because for a like doing a public key, like a public key, you used to encrypt a message, but you cannot use it to assign that message. You have to go to the public key, the private key. So I'm thinking because maybe the public key is related to that kind of encryption, that kind of thing.
Okay. I love this. That's good. Yeah, I'm proud of you guys. It means you guys are following me. So just like the first and second person said, if you look at the whole processes involved, right, you'll find out that what is being hashed is the document. The public key is not hashed. You understand? The public key is being attached to what is being hashed. So it means that since the public key is not hashed with the data, is only attached to it, so it's easier for them to use this algorithm to retrieve the public key from the signature and transaction hash. Because look at the diagram, right? From here, you hash it. After hashing it, you use your private key to sign. So here you're already having a hash plus signature. Then you now attach your public key before sending it. All right. So now what this algorithm does is now to go and fetch out that public key. So this algorithm is just like he's trying to separate the hash, encrypted hash, and from the public key. Because the signed document contains the encrypted hash and public key. So that algorithm, what it just does is to go and pick the public key. So do we understand now the question I asked and the answer? So you guys are good. I love that. So the last stage now is that the derived public key is hashed using KCAC 256. So I want to ask a question. Since we are assuming that this is Ethereum, if this is were to be Bitcoin, what would be this KCAC 256? What would be there if it were to be Bitcoin?
I
256.
It
think
will be sharp
two
256.
Ah,
fifty six.
Kai. 20 crate of beer for you guys. I love this. I love this. I'm impressed. Okay. And the last 20 bytes of this hash gives sender's ETH address. This address must match with the address of the sender. So, do you guys remember? I think there was somebody that asked a question that which one is better? Is it using address or using public key? So, you can see what is happening here. They said the derived public key is hash using KCAC 256, and the last 20 byte of this hash gives the sender's ETH address. That's the sender's Ethereum address. So if you remember, I was trying to explain that, okay, public key, your address, wallet address is like a compressed form of your public key. So they say this address must match with the address of the sender. If it matches, the network accept the transaction as valid. Of course, if it doesn't match, it will reject the transaction. Why? Because it shows that the transaction is invalid. So all of these checks, because there's no intermediary to confirm all of these things. So all of these mathematical checks is to ensure that everything is being done the way it is. Nobody can go and fraud the system or cheat the system or game the system and all of that. All right. So any question before we move to the next one?
I have a question, sir.
Okay, go on.
Okay, in the number 3, it says the derived public key is hashed using KCAC 256.
Yes.
And the last 20 bytes of this hash gives the sender's ETH address.
Yes.
So what he's saying now is the last 20 bytes, is it the last 20 characters of the public key that it's meant as bytes?
Yes. Now,
Okay.
if you did, yes, I love that question. Now, if you did low-level programming like C, not really low-level, because if somebody say low-level is assembly language that I consider as low-level. I don't still consider those C Rust as low-level. I just consider they are system programming language. So if you have done system programming, you find out that each character is a byte. You understand? Your character A is 1 byte. Character B is 1 byte. So if you are saying 20 bytes, it means just like you say, the 20 last characters. Don't mind programming. They just want to be sounding tush. Instead of them just say 20 characters, they say 20 bytes. All right. But they're actually correct by using bytes because there are special kinds of character that exceed 1 byte. For instance, the Arabic character, a particular character can be up to 4 bytes. So that's why most times they used to be specific 20 bytes. So that you know that it's actually those, it only contains character whose size, each of those characters has a size of 1 byte. So any other question? Okay. So no question. Let's move on. So next, say how Bitcoin and Ethereum use cryptography. Bitcoin uses, sorry, there's a spelling error here. It will be corrected. Forgive me for that. So Bitcoin uses SHA-256 for hashing blocks and transactions, and ECC for key pairs. Now, this ECC is elliptic curve cryptography. Ethereum uses KCAC 256 for hashing and ECC for keys/signatures. So it means both Bitcoin and Ethereum uses ECC for their keys, in generating their keys. We would have maybe on Saturday, I think we're having dev hour. We'll look at the mathematical part of getting, I told you that your private key, you can determine what your private key is. Now, your public key will always be derived from your private key. And that's why you always see they call it public-private key pairs. That's why they call them key pairs. It's because the public key is always derived from the private key. So on Saturday, please, if you are free, you have the time, come to Dev Hour. I'll show you guys the mathematics behind it. Nobody say we go solve math, so 4 person go say, "Oga, I know they do." All of us must do one. We are not solving math. It's just that I want to show you the inner workings, how these public keys are gotten from private keys. All right, it's not something difficult. So transactions, it says sender signs with private key, network verifies with public key. So, and this, how, why they do it this way is so that your private key will always be with you. You only sign, just like how your stamp, if you go to an office, the stamp is always in the office. All right, they don't give you access to the stamp. What they give you is access to the document that is being stamped. That's the same thing that is happening here. What you send to the network is the signed document. That's what is accessible to the public. All right, and not the private key that is used to sign it. So that's exactly why they decide to go this way. You sign with your private key is still with you. You don't need to share it with anybody. The network verifies it with your public key. So take note of that. So elliptic curve cryptography is a type of asymmetric encryption that uses math based on elliptic curves. So just like I said, during dev hour, we'll look at this and discuss more on it. All right. So role of cryptography proofs. One, ensures that no one can spend your coins or digital assets. For anybody to be able to access any of your digital assets, they must have your private key. If they don't have your private key, they can't have access to your digital assets. Next, links transaction in a tamper-proof chains. You know, we talked about this. We say hashing is why you hash the information, your transaction is so that nobody can actually go back and change anything that is there. It makes it tamper-proof. You can't tamper with it. So next is provides transparency. That's anyone now can go and verify the transaction you did. Now, right now, if somebody say he sent you money through your bank account, you rely on your bank to send you a credit alert to show that the person have sent the money. Now, imagine an event where your bank is having network. It's possible that from the person's bank account, they must have debited him. But you have not received it. Why? Because you are depending on the bank to verify the money the person sent and then credit it to your account and alert you that, okay, oh, so person send you money. But for blockchain now, the transaction is open. Although, mind you, they are private blockchains. There are some companies that makes use of private blockchains. All right, like IBM have their own private blockchain. But blockchain we are looking at in this aspect is those public blockchain. So the information is always in the open. You can go to your block explorer, you understand, and check up on it. Like this is an explorer for Ethereum, right? You can always, once you get your transaction hash, you can copy it, come to search, put it there, and then, or you even check somebody's address. From there, you can confirm all the transaction. If you say he sent you something, you can take his public address, paste it here, search. It will show you all the transaction he has run, the exact time, and the specific amount. So that's the beauty, right? Okay, sorry. You see, I was speaking and I just share one part of my screen. So you're not seeing the other part that I was talking about. So I'm coming. I was thinking, okay, so this was what I was saying. So now if somebody, sorry, is small, let me see if I can increase the size. So if somebody claims that he sent you money, you don't need to wait till the money land. You can get his public address, come here, paste the public address here, search. Once you search, all the transaction he has done will come out. From there, you can see the time he did the transaction, how long ago, the date, the specific time, and then the amount and all of that. So that's why here you see they were talking about okay, I think this is better. That's why here you see they are talking about that it provides transparency, right? Anyone can go and verify any transaction. So this process is a process we have seen before. So I just put it here to be able for, repetition matters a lot in learning. And once you see something repeatedly, you tend to understand it more. So that's why I put it here too. It's for emphasis sake. So you have private key, signs transaction, public key verifies, and then added to the blockchain. So this is the process involved for any form of transaction. You take your private key, you sign your transaction. Of course, after you must have hashed the transaction using your hash function. And then you attach your public key to it, and then you send it to the blockchain. And when they now verify your public key, They will now add it to the blockchain. Yes. So any question? Okay. And one thing, sorry, let's do an activity. So quickly, I need somebody to give me their name. Let's perform in a hash. So I'm going to send this website. All right. In fact, let me even send it now to the chat. So if anybody that has a system or his phone can quickly do this. All right. So let's hash. Somebody should tell me their name. Let's hash. I want us to hash a name. So this hashing, right? Look at it. You come to
Johnson.
hashing. Okay, are you guys seeing it?
Yes, we can see it.
Okay. So this is, you come to hashing, that's this left side, and then you look for SHA-2. Now under SHA-2, they are different. Then you double click on it. Once you know, I told you that there are different kinds of SHA, so you can see them. So if you come here under this SHA, you make sure you come and select 256 because that's the hashing of Bitcoin. Don't select 512. Select 256. So now you can see that here is telling you that it's going to always give you an output of 64. All right. So you can see it's already hashing our space. So somebody should quickly give me their name. Let me hash somebody's name. Okay, let me hash Sir George's name. So let's say Sir George. Now you can see the hash, the output of Sir George. So if we count this thing, I'm telling you, this thing is going to be 16, right? I say 16. It's going to be 64 bits. All right. Now, this Sir George, imagine that we just come. Remember what we talk about hashing, that a very little change will cause a tremendous change in the output. So let's just assume that we just add full stop. We just full stop now. Let's just come and add full stop after Sir George. Now, observe what you are seeing here as the output. All right. Look at what is here as the output. Now, let's add full stop. Now, does what we have here, does it resemble, like, does it look like the change we made is just a small change? You find out that it doesn't, right? Look at it without full stop. Look at what we have without full stop. Look at what we have with just a full stop. So that is what hashing, right, is all about. So I've dropped the website. Normally, what you guys are supposed to do is to hash your name and share the result. So if you have access to your laptop or your phone, and you can do this right now, I've dropped the link in the chat. You can hash your name and then send the results, all right, on the chat. Yeah. So we are supposed to do this group discussion, but just like I said, we are way behind time. So we'll leave this till probably Saturday, or if we're able to finish on time today, we'll come back to this to have this group discussion. Very, very important. So before we move to today's class, is there any question? Is there any challenge? Or does anybody want to take over? Say, mentor, go and rest. Let me teach today's class. Yeah, I'll gladly accept. Me too, I want to learn.
I have a question, sir.
Okay, go on.
So we just did hashing now, hashing a name. So I want to
Yes.
ask, does it necessarily, do we have to take note of uppercase or lowercase, or it can work both ways?
Beautiful. I love that question. Now, you have to take note of, it takes note of both uppercase and lowercase. So for this E, right, look at the hashing with small letter E. Now, let's change it to capital letter E. Is it the same thing? Look at it. Look at small letter E. Look at capital letter E. So is it the same thing?
No.
Good. So it means it takes cognizance of uppercase and lowercase, because if you look at in English language, they are the same thing. Capital letter A, small letter A, all is A. But in mathematics, if you are looking at the ASCII code, you can do a search on that ASCII code. So let me just see if I can get a very nice table that shows that. I hope so. This thing is too small. It's too small. Okay, I hope you guys are seeing this. Now, in ASCII code, right, you find out that capital letter A is reading 65 in decimal, whereas small letter A is reading what? 97. So mathematically, they are not the same thing. That's why even in hashing, All right, even because this is a representation of characters in mathematics in both decimal base 10 and hexadecimal base 16. So you see, A in hexadecimal is small letter A is 61, capital letter A is 41. So that's why hashing too, it will be different when you are hashing a capital letter or an uppercase or a lowercase. So does that answer your question?
Yes, sir.
Okay. So is there any question?
Yeah, I have a question, sir.
Okay, please go on.
All right. So, seeing now that the hashes, the concepts are gotten from the ACID table, like that table you just shared, doesn't
Yes.
that kind of like makes it in a way like symmetric? Seeing that maybe if you use the if you follow keenly, maybe the ACID table, you can see what characters there are in the hash. Seeing that you know that A is maybe this one is for two. I don't know
Okay,
if
okay.
that can,
Actually, this ACID
yeah,
table.
more clarity on that.
Okay. This ACID table. Okay. Like it's just to illustrate. I just brought it up to illustrate to you how system-wise computers don't see uppercase and lowercase the same
Okay,
as we do
that
in
makes sense.
English language. You know, no be
That
English,
makes sense.
computer don't understand English
That makes
language.
sense. That makes sense.
You understand, right? Yes. So that's why when in hashing, right? If you are hashing, capital letter and small letter will always give you a different this thing. A different this thing. What are they calling it? Results. Because mathematically, they based on computer mathematics, computation, they don't see it as the same thing. So we good to go? All right. All right. I love that. So quickly, let's okay, go
Sir,
on.
the link you
Oche.
dropped is not going to. Yes.
It's not going through. Hope you
No,
are not
I'm
easy
using
there
MTN.
or glue.
I'm using MTN. The link is not
Ah,
going.
that's serious.
The one for the
Let me
ASIN
drop
side
it
is
again
not
because I
going.
saw that somebody have done his own. He has even dropped. I think somebody has even dropped the
Okay.
results. I think I look at two people. Oh, many people say not just two. I love this. Try
All
and check
right.
again. All right. Yes.
So please, is the setup on the site, the setup.
Okay, the setup. I'm coming. Let me. Sorry. Oh. Hey, this thing want me to go full screen. Me. Okay, no problem. I know what to do. So, any question? It's just paining me that the question I'm supposed to ask you people now, we have already answered it. That's the only thing that is paining me this morning. Hmm. Hmm. You people are laughing. Don't worry. I'll still catch you people. Hmm. Oh. Okay. So this is the setup, right? Once you enter the website, you come to this place, you see operations. So all these ones, you can check for the operations, public key, you can see encryption or encoding. So, but our main target is hashing. So you come to hashing, you can see compression too. You can see encryption and encoding. You can see the different kinds of encryption we have and encoding. So you come to hashing, and then under hashing, you come to SHA-2 because 256 is under 2. You double click on it. Make sure you double click on it. And then once you double click on it, if you're having 2, remove 1. Yes, because the thing is that hashing, you can hash a something twice. That's after you hash it the first time, you can take what you hash and hash it the second time. In fact, you can hash something up to 10 times if you want. Do you get? So here, you make sure you select 256 because that's the hashing mechanism that is being used by Bitcoin, not 512. So you select 256 here, and then here you come and enter your name here. Once you enter your name here, you check the output here. So are you okay with that?
Yes, sir. Thank you.
All right, you're welcome. So Let's go there. Mm, why is this team misbehaving? Okay. So any other question before we go to another? Okay. So are you guys seeing? Beautiful. All right. So today we'll be looking at smart contracts. And under smart contracts, what we'll be targeting is what, why, and how. That's more like the three most important things: the what, the why, and how. So let's see. Now, under smart contracts, these are some of the things we'll be looking at: introduction to smart contracts, why smart contracts matter, how smart contracts work, risk, and limitations. So now, what are smart contracts? Okay, a smart contract is a self-executing program that runs on a blockchain. It automatically enforces the terms of an agreement when certain conditions are met. They are like digital promises, but written in code. They automatically carry out agreements when certain conditions are met. That's, they don't need anybody to come and enforce them. Hmm? It's not like a 2-year-old child that you have to wake him up from sleep, you have to bathe him and dress him up for school. In fact, in the process of dressing him up, he's still even crying that why you have cut short his sleep and all of that. All right. So these are what smart contracts are. So the take, just put it at the back of your mind that they are self-executing programs that runs on the blockchain. No smart contract runs outside of the blockchain. All smart contracts runs on the blockchain, and that's why smart contracts are synonymous to the blockchain. It's only when you come to the blockchain space, the Web3, you'll be hearing things like smart contracts. Why? Because they actually run on the blockchain. So take note of that. And they are automatic. Why are they called smart? They are called smart because once the condition in which they are being programmed is being met, they automatically kick off. So now, let's say, for example, I believe you guys know automated vending machine. That's, if you watch all those old movies, I think even the most recent movies, there are some of these machines where you can just go and put in coin. And once you put in coin, you find out that it will bring out a drink for you. So those are actually vending machine. So in a vending machine, you just need to put in money. And the money you put in, the amount you put in is equal to what you are getting, the drink you are getting. You understand? So once you put in this money, which is the condition for the vending machine to give you your drink, the next thing is the machine will give you your drink, right? Why? Because you have met a condition, which is putting in the money for the drink. So next, the machine will do everything and then deliver your drink to you. So that is exactly how a smart contract works. But it's just that, just like I said, smart contract works or runs on the blockchain. So any question?
I have a question, sir.
Okay, go on.
So is smart contract a type of machine learning, or is it? I don't know how I'm going to explain. Is it a type of machine learning,
Okay. It's not
or is it
actually.
related to machine learning?
No, it's not. Smart contract is not machine learning, is not an AI. It's not related to artificial intelligence in any way. All right. It's just a code that is being done in such a way that it's always working with you meeting a condition. Once you meet the condition, it's going to give you the results. All right. It's just like some of us, where your dad will tell you, if you carry first, I'll buy you bicycle. Meanwhile, some of your dad know that you not carry that first, but so that you not come and disturb them, daddy buy me bicycle. So they put it at the back of your mind that, okay, for you to get bicycle, you need to carry first, right? So it means there's a condition, And once you meet that condition, that's once you carry first, your dad is supposed to buy that bicycle. So that's how smart contract are, the way they do them. All right. It could be that maybe, let's say, for instance, a smart contract that involves or that helps you borrow. The smart contract can be like, for you to be able to borrow any amount of money, you have to have at least 30% of that money in your wallet. So let's say you want to borrow $1,000, right? So roughly 30% of $1,000 will be around $300. Mona no mind me, I know sabi mathematics. Or somebody say this guy in done dey wrong. I feel they wrong. Yes, not true. You know, like, so now it means that for you to be able to borrow $1,000, you need to have about $300 in your account. So that is what the contract checks. Now, immediately, once you want to borrow that 1,000 and you don't have up to that $300 in your account, in your wallet, you find out that it will be impossible for you to borrow that $1,000. But immediately you're able to transfer an amount of money that will make the money in your wallet to be up to $300, you find out that automatically you'll be able to now initiate that borrowing of that $1,000. So that is just how a smart contract works. So any question? So now let's look at why a smart contract
Sure.
actually.
Sir Gideon, I think some hands are up, so
Okay.
probably you could check. You could unmute.
Okay. Please, if your hand is up, you can speak. You know, I always tell you guys to unmute because most of the time I'm not really seeing everybody.
Okay,
So please, if your hand is up.
okay, just to gain clarity, based on what you just explained, that means like all these airdrops that we usually see that means they are smart contracts because because like
Yes.
you have to do certain tasks
Yes.
before you get the amount. So so they are
Beautiful.
smart contracts, right?
Yes, they are. So any other question? Please don't be shy. Anytime you have a question, just unmute and ask. All right. Because just like I said, I'm not really seeing the screen. So I think Ocha is raising up his hand. Please go on. Okay, so maybe it's a mistake. So now let's look at why are smart contract actually interesting, right? Let's compare them with the traditional contract. We all know contract. So agreement is agreement. I know some of you have sung the song. You used to sing the song. So now let's look at what is now the difference between a smart agreement and a traditional agreement, because contracts are just simply agreement. All right. So now we'll be looking at under each of these aspects. Now, in terms of format, a traditional contract can be paper or digital. So, but a smart contract is fully digital, is code. You can't find a smart contract that's not digital. All smart contracts are digital. All of them are actually code. So take note of that. But the traditional contract, for instance, maybe you want to buy a house, or maybe you want to buy a property, or maybe you want to get loan from the bank, you find out that you have to do a lot of paperwork. You have to sign this agreement, you have to do transfer of ownership, a lawyer have to, you understand, all those kind of things. So for enforcement, for your traditional contract, you need people to help you enforce it. All right. For instance, now, if you look at you want to buy a house or a property, you need to bring in witnesses, those that like witness that yes, the person that sold this land is actually the owner of the land. Whereas that's from the buyer side. And then the seller to have to bring his own witness that will say, okay, oh, yes, oh, truly, like this person, I was there when he was getting this land. And then they have to do some kind of paperwork where they have to bring in lawyers and all of that. At times, they have to even go to the point of settling the state. A particular, like, let's say maybe in Kaduna now, or Lagos or Abuja, probably there's a percentage you have to pay to the federal inland or so. I don't even know which people, but I shall know that probably there's a particular amount you have to pay them and all of that. Whereas for smart contracts, let's say you are getting something like a house and you are making payments with crypto. Like, you don't need all these people. You don't need all these people. It's automated already by the code. It's self-executing. I pay you, give me my house. Things like that. All right. So the next one is speed. Now, if you are looking at traditional contract, sometimes or most times it takes time. You need to go there and check, is this person really the owner of this property? You need to check, does the property has any outstanding tax? Does he have any outstanding dispute? So you have to check all these things. The signature on it, is the owner of the property, is he really his signature? So you have to do all of these things to ensure that what you are buying will not shoot you in the foot. All right. But now for smart contract, it's instantaneous. You just do one, piam, it has gone. All right. Now the next one is okay. For instance, I remember then I used to go to the bank, and then I see people that want to go and send money or receive money through all those see me, I wanted to say money points. Sorry, not money points. All those people that get money from abroad or receive money from abroad. There is I've forgotten the payment system they used to use.
Western Union.
Good. If you like the Western Union, they ever show you shege. This one way remember their name like this. Okay, so all those Western Union, right? Like, I've seen where some of them talked about it. Some of them said they had to wait for days. Others have to even go to the bank up to 3-4 times. So imagine you are in a state of emergency. It's a money you need immediately. You can't force Western Union to give you that money immediately. They have to verify, they have to check. Sometimes the delay, once it's weekend, Saturday, Sunday, the hotel is non-working days. Those days are not business days, so nothing concern them till Monday before they will now start processing again and all of that. But if it's smart contract, it's just for you to tell the person, send me your address, and then in less than 1 minute you already seen the money in your wallet. All right. The next one is tamper proof. So is traditional contract tamper proof? No, it's subjected to fraud. Anybody can go and change anything. All right. And the bank can just wake up one day and say, from today, I'll be charging people 100 naira. And they'll end up charging you 200 naira. And you can't do anything. You can't do anything about it. You have to accept it like that. All right. But for smart contract, it's not like that. It's tampered proof. Nobody can go and change anything. Once it's been deployed, it can't be changed. It can only be upgraded once it's deployed, but it can't be changed. All right. So the next one is trust. For traditional contract, you need to trust the people. For you to receive money through Western Union, it means you trust Western Union to deliver the money. In fact, you don't even have a choice than to trust Western Union and to trust the bank through which you are processing that payment. You understand? So you need trust. Whereas for smart contract, you don't need to trust the person. You don't need that. So because if the person is going to cheat you, it's going to be detected by the smart contract and the transaction won't be successful. So these are some of the advantages of smart contracts over traditional contracts. All right. So any question? Okay. No question. This class they hot. I see they hot. So let's look at key properties of smart contracts. So key properties, that's what makes them smart. What makes them smart contracts? Now, one is self-executing. I think we have talked about this already. We say they execute automatically when conditions are met.
I have please.
Okay, go on.
Yes, I've been thinking. So these smart contracts are lines of codes that performs tasks automatically, right? And
Yes.
then they are being deployed on the blockchain. And then when we were discussing transactions, we saw that there are algorithms that still perform transactions on the blockchain. So
Yes.
I want to know, please, what is these key differences between these transactions, these lines of code, and those algorithms that still work on the blockchain for transactions to be successful? I just want to know.
Okay.
Or generally, all of these things are called smart contracts. or is there a difference
Okay.
between them and
Okay. So now, where we were coming from, right? We are talking about cryptography. So the whole essence of cryptography is just for security, all right, and verification to check whether something is genuine or not. Are you getting it? And all those things, right? Some of those things are still code. So you can still refer to them as smart contracts. But they are not really doing the main work. The main work they are doing is just to check, make sure your transaction is tamper proof, make sure the transaction you are sending is getting to the right person, and make sure the transaction that is being sent is verified, whether truly is being sent by the owner, and make sure the person receiving it is the main person that is supposed to receive it. So all those cryptography part aspect, that's what they deal with. All right. So you will find out that even they, so far they are running on the blockchain, they too are smart contracts. But in this case now, this smart contract we are looking at in particular is the one that have to do with utility on the blockchain. That's what we really make use of. For instance, now your bank, you transfer money or you use ATM card to pay, Visa, MasterCard. I know some of you will just feel all those cards are just names. No, they are real company. Visa is a company. VAV is a company. MasterCard is a company. So if like you use MasterCard to purchase something, right? MasterCard is now more like the middleman in between your bank and the payment merchant. That's the person you are paying to. All right, they are not like the middlemen. So in your payment, what concerns you with MasterCard? You know that you paid money and you are paying it from your account to the person. So what you want to see is money debited from your account, in as much as you don't want to see money debited from your account, but at least it's expected since you made the payment. Money debited from your account, and that same money that was debited from your account is also credited by the person you are sending it to. That's what your concern is. The one, everything that used to happen in between does not concern you. You understand? So it's the same thing that is happening here too. We are just looking at those part of the code that actually help us do whatsoever thing we want to do, from we the sender to the person receiving it. Be it maybe we are transferring a digital asset, making payment, and all of that. So everything that is happening, the in between, the verification, the tamper proof is not really our concern. You understand? So that is actually why we are now looking at this one in particular, smart contract, whereas that one as cryptography and the rest. So I don't know, does that answer your question?
so from what you said, now this one is like for utility on chain, that one is for verification and authentication on chain.
Exactly. You understand?
Okay.
Yeah. And the build and that other one, the cryptography aspect and the rest, it must not necessarily run on the blockchain, because majority of wallets, crypto wallets, that's what they make use of. And that's why you can see you can generate your private and public key using your wallet. You understand? You initiate a transaction from your wallet. Your wallet help you sign the transaction. So all these processes, the wallet is doing it before it even gets to the blockchain, because it's after you do all these things that it will now push the transaction to the blockchain. And then on the blockchain, what is going to happen is that verification will now happen on it. That's when those running nodes. I know they have taught you guys about nodes last week. Those running nodes will now verify the transaction, confirm if it's really coming from you or not, if it's valid or not. So do you get?
Yes, sir.
You
Yes,
understand?
sir. Thank you. Yeah.
Right. You're welcome. Okay. So we talked about self-executing, then trustless, right? So when they talk about trustless, it simply means you don't need to trust whosoever you are dealing with, because the code itself will enforce that contract. You understand? Unlike the traditional way where somebody can promise you, if you do this, I'll do this, you do it, and the person did not do his own part. No, this time around, this code will enforce it. It will do it in such a way, if you do your own part, the other part too must be fulfilled. Because why? It's going to carry out that part automatically by itself. So that's trustless. Then the third one is immutable. So once that code is created, it cannot be changed. So you can't just, unlike banks now, banks can say, formally, those using OPay, they used to transfer, no charges. One day, OPay just woke up and say, from 10,000 above, 15 naira. You understand? Like that, you can't do that on a blockchain. You understand? You can't just call one morning and then do a U-turn. Say, we are going to east. I say, no, now we are moving to west. No, you can't do that. So once it's created, the code can't be changed. So it's reliable. Anything you are having as a smart contract, you can rely on it that this is going to continue going. Although it can always be upgraded, but it can't be changed. It's immutable. All right. So the next one is transparent. Is anyone can verify contract logic on the blockchain. So just like I showed you guys, where I came to the Ethereum transaction scan, that's etherscan.io. You can go and verify any transaction of your choice if you want to. It's open. It's not that it's something they went and hide somewhere. It's in the open. So anybody can actually go there, verify, see that, okay, it's true. This person actually made this transfer. This person actually carried out this transaction and all of that. So this picture is just to illustrate, right? Where your smart contract, you have the parties involved. The smart contract is there for the execution of the contract between the parties. Whereas for the traditional contract, you have parties involved. You have the contract where they agree. That's the agreement between them. And then you must have a third party, right? Be it a bank, a lawyer, whatsoever. So it's this third party that will not help in the execution to make sure that, okay, nobody is cheated. Make sure the agreement is being enforced. But for this one, you don't need any third party. The smart contract itself, the contract itself is smart enough to know what it's supposed to do and what it's not supposed to do. So any question? Okay. Today is just paining me that I've not seen question to ask. Don't worry, I'll soon see question to ask. So why smart contracts? Is it why should we care? Right? Why? At least we are looking at we have looked at what is smart contract, right? So what are smart contracts? Now let's look at why. Why smart contracts? So now one is that smart contracts are now eliminating intermediaries. That's they are removing middlemen. Unlike how we deal with transactions before, you always have middlemen, right? Now smart contract are okay. For instance, now let's say you want to convert, maybe you have dollar, maybe you went for a wedding, you dance. One man and spray, now give you $100. Say, kai, make I reach that buri the change. Guy waiting my street, man go change this thing to naira. Mo go flex 1 or 2 this week. Now you see that you need the buru the change guy to be able to change your money for you. And now by the time you get to the buru the change guy, he might decide to look and say, after all, I'm the only buru the change guy here. So any amount, any price I give this guy, he will likely take it. All right. But let's say now you have maybe Bitcoin or Ethereum and you want to change it to USDT. You understand? Like you can just use your wallet or whatsoever and just do a direct conversion. You don't need a middle person to do that for you. So that's what smart contracts are doing. They are eliminating intermediaries. And by eliminating intermediaries, they are saving time and money. Because let's say, for instance, you need to do something in the middle of the night, and then you are relying on a bureau de change guy. Of course, you can't expect him to leave his house in the night and you people will meet somewhere and do the transaction. It's not possible. You understand? So you have to wait till the next day in the morning. But if you are dealing with smart contract, if you like, wake up around 2 a.m., it will work. 3 a.m., it will work. You understand? So it saves time it also saves money. So for instance, now you are dealing with if you are in Lagos, right? You are staying in Lagos or Abuja, you find out that you want to rent a house. They will tell you that rent fee is 800k, agent fee is 200k, legal fee is 100k. You understand? So imagine you are making use of smart contract to pay that rent or to get that house. You find out that what will you need agent fee for? That one is eliminated. What will you need legal fee for? That one is eliminated. All right. So it saves time, saves money. Secondly, is automating process. All right. So smart contract automates real world processes. We have talked about that. All right. They do tax, they carry out tax automatically. So far you meet your own part of the deal, the other part will be carried out automatically. You don't need to wait and say, Butalik, be Vitalik, owner of Ethereum. Now him I just dey wait for. So then go just go press accept for this my transaction. What I want to do now. No, you don't need to wait for anybody. It just works, right? So this one is just an illustration where you have a buyer and a seller. A buyer sends whatsoever money he's sending, and then the smart contract takes care of everything. All right, and then forward the money to the seller. So that's just why smart contract. So number one, eliminate intermediaries, saves time and money, automate process, making life easier. All right. So any question on that?
Hi, sir.
Okay.
Okay, so you said why smart contracts? The first reason, eliminating intermediaries. Now,
Yeah.
in previous classes that we've had, we've come across gas fees for processing transactions. So now
Yes.
you mentioned changing from one currency to another. Let's take for
To another.
instance, you want to change from USDC to USDT. So I
Yeah.
want to ask, I have like 2 or 3 questions in one. I want to ask,
Okay.
changing from one currency or from one network to another network, does it burn gas fee? That's the first one. So now that we've
Okay.
claimed that it eliminates intermediaries, why do
Yeah.
miners still have to get a percentage of what we are of the transaction that we are trying to make, since it is sent to them in gas fee? I understand that they have to get paid for computation and all those other things because their devices carry a lot of power. You
Yes.
understand? So now
Yes.
that you said it eliminates intermediaries, does it fully satisfy this claim that it eliminates intermediaries, since these miners still have to get a percentage of what we are sending or a percentage of our transaction?
Okay. So now, if you look at what miners are doing and node, those running node and those mining, what they are doing is to keep the network, let me not say, safe. Yes, and to keep it running. So their job is that they verify and they validate, which is very, very, very important. And even that verification and validation is not they themselves that are doing it. It's the program they are running on their computer systems or whatever systems they are using that is actually doing all of that. And it's doing all of that automatically, right? And when you talk of miners, right, because those that run node, like it's not everybody that run node that actually mines. You understand? And those that mine run nodes, but it's not everybody that run nodes that actually mine. Some are just validators. They just check whether a transaction is valid or not. They help in verification process. But those other ones that mine now, what they are doing is that they are helping to create new currency. For instance, the Federal Bank of Nigeria, another the Federal Bank of America or whatsoever, they are there to do what? To mint new cash, to make more money available. So that is what these miners do too. They help to introduce new coin into the blockchain, or be it Bitcoin, be it Ethereum, and the rest. Yes. So it's not as if they are the ones even carrying it. It's the program they are running. It's just that the program needs to run on a computer or on a system, and they are now providing that computer, that system, and that internet for it to do just that. That's one. So the gas fee they get, the reward they get in terms of gas fee is like an incentive for them to keep the network up and running. Because imagine you are running a node, you are burning electricity, you are burning data, you are burning your system resources, because it takes a lot to run a node. And then somebody say, will not give you anything. Even if now you go do the work, you don't go do that. So those gas fees, a way to incentivize those validators, because they are the ones that protect you, they shield you from those that are coming into the network to sabotage or to fraud. All right, so that's why they are being rewarded in terms of gas fee. So that gas fee is like a reward to keep on doing what they are doing and to encourage them. So I don't know if that answers your question.
It does partially, but we
Okay.
can continue. I'll read
No.
on the rest.
Okay. So another thing is that you can look it at, like, you can see it in this view. They are providing an infrastructure for the blockchain to keep on running. So they are being paid for providing that infrastructure. You understand? So it's not as if they are sitting on their screen and they are checking. This guy saying send $20. Nana. How you take send that? Nah lie. Where no be true. Stop him. Put invalid. No, it's not that. They just run the program and leave it. The program itself executes the verification, validate transaction on its own and all of that. But you can read more on that. Yeah, I believe you have more understanding on that. So what do we have? So any other question before we move to use cases? Okay, so let's look at use cases. That's real world. Okay, somebody is speaking. Go on, please.
Good morning, sir.
Good morning, sir.
For P2P,
Yes,
is
sir.
he also a product of a smart contract?
This guy. I was trying to avoid P2P and somebody brought it up. Now, wow, these students, people are wise. Okay, so for P2P, right, peer to peer. Now, P2P is another aspect of blockchain on its own. Do you get it? And why is it
Okay.
called peer to peer? Okay, for instance, now, Lightning Network. Lightning Network is like a layer 2 of Bitcoin. They also
Mhm.
implement internally peer to peer. All right, but other centralized exchange as well, like Bybit, like BitGet, they also have P2P. So peer to peer is also a concept of blockchain, a concept of decentralization, in that you are dealing directly with the person.
Okay.
You understand? You are dealing
Yeah.
directly with, nobody is coming between you guys. You are dealing directly with the person. But it's just that because you know how human being is, you don't always expect somebody to hold up to his own game. So now
Yes.
have like an intermediary. So
Hmm.
for instance, for people that use Bybit, that's why you see Bybit coming in between. So Bybit will tell you, you want to sell a coin, the person you are selling it will have to transfer the money to you. And then Bybit will now tell you that, check, confirm that the person actually sent the exact amount. And once the person sent the exact amount, they'll now ask you to release the money to the person. Now the money is already on their platform. All right. They are now serving like an escrow between
Yes.
both of you. You understand? So if anything goes wrong, they'll know how to come in to minimize the loss from both sides or from any party that is feeling cheated.
Yes.
Do you get it?
Even Bybit locks your fund immediately you
Good,
initiate the transaction.
good, good. So you understand? So they still pick that P2P, peer to peer, from the decentralization, but it's just that some of the chains are not able to effectively implement it. But if you go and read on the Lightning Network, their P2P, they did that if like effectively. And for those that used to download, what's the name of this? Why did I forget this? Torrent. Some of you know torrenting. Okay. This one everybody is quiet.
Torrent website.
Yes, torrenting.
Oh,
Okay. Some of you know
do you
Onion, the Onion network. You know Tor, Tor.
Yes.
You know Tor has a browser, Tor browser.
Yes. Yes.
So Tor in itself is a technology. That one you know,
Mm.
like it's called the Tor browser. It's actually the open. I said the open network. Hey God.
This one.
So, yeah, so Tor has a browser. Now that Tor implements peer-to-peer. How does it implement peer-to-peer? Once you are browsing, right, on that Tor, what it does is that it connects your computer to another person's computer that is online, to another person's computer that is online, till it gets to the final destination you are going to. And it masks all this connection, it encrypts it in such a way, no, like at any point in time, nobody will know, like you now, you won't know which computer your computer is connected to. And the next person won't know the person's computer, which his computer is connected to. And it could be anywhere from anywhere around the world. All right. So that is also a kind of P2P. But just like I said, right, it's not really easy to manage peer-to-peer. And that's why I see most of these centralized exchange, they do a kind of escrow system, a peer-to-peer, an escrow system of peer-to-peer, P2P. So that is just it. So I don't know, does anybody have any question? Yeah, these guys. I want run from P2P, person draw me back, say, bros, come back here, come back here, come back here, come back here. Okay, no problem. So now let's look at real world use cases. Decentralized finance, DeFi. All right. So when you talk about DeFi, you're talking about decentralized finance. It's actually finance that you know, like bank and the rest, but this is now a decentralized one, the one that does not really need a bank or an intermediary or a third party. So under DeFi, there are applications, web applications, app applications that runs on the blockchain that are involved in borrowing, involved in lending, right? Just like how banks too is. So for instance, applications like AVE, you can check it out, AAVE. I think they even have API endpoints that you can even make use of. I'm not too sure though. If it let you earn interest on your money directly, that's on the money you lend to people directly, they help you earn interest on it. And all is being done in a decentralized manner. Although I don't really know how the technology works. I know there was one time I was looking at it, but I did not really study it much. So sorry, I can't talk much about the technology behind it. But it runs on the blockchain. It's a blockchain, it's a smart contract, but I can't really tell you for sure how it works. So secondly, we have non-fungible tokens, NFTs. I know many of us knows this. All right. So these NFTs, they are just like unique digital items. It could be an artwork. I know most of us know NFT as monkey. You see one monkey guy face.
Board ape.
Ape, thank you. So NFT is beyond ape. I don't know what gave them that inspiration that they should be using ape. Imagine, lion suppose they verse. Now I'm be king of jungle, but now ape they still use do NFT. Kai. So like art or game items, like right? It could be art, it could be game items. Now there are some games, some gaming blockchain based games, all right, that have some kind of in-game items like the shield, like the
what are we
sword
going
for
to
fighting
do?
games, all right, like shield, like sword, like helmet, all right. Now all those things now they can do it in such a way you as a player can decide to own a unique shield. That shield is unique to you, like no any other person on that game has that particular shield. Or maybe yes, somebody might have the particular shield, but the function your shield is performing will be different from the function the other person's shield is performing. So these are all where we can apply NFT. And probably in the game, they can do it in such a way, if somebody wants your shield and you are willing to sell it, you can sell it to the person, do a kind of transfer, and the person reward you with an in-game point or an in-game money where you can use to also purchase another game item. So that is it. So you can check that one. You can check OpenSea. I think OpenSea sells a lot of NFTs, and these are examples, at least majorly the ones people know: ape head, cartoon head. But NFT is beyond that. You can have your certificates in NFT. So it's just like, your traditional certificate is meant for you. If your son cannot take the certificate and go and use it, your elder brother cannot take the certificate and go and use it. It's meant for you and for you alone. So we can also have a non-fungible token as a certificate in such a way it's unique to you. Nobody, no any other person has a copy, that particular copy of that thing. So that's another application. There are other applications though, but these are the ones at least I can speak on for now. So the next one, we have decentralized autonomous organizations, that's DAOs. I know some of us must have seen these DAOs. So anywhere you see DAOs, right? DAOs are like organizations that run without a head, a central head. So now somebody might ask, is it possible to run an organization without a leader? Yes, it is possible. Now, how is that possible? In fact, that is how blockchains are being run. That's how the Bitcoin is being run. Bitcoin don't have any leader. There's no person you go and pick in Bitcoin and say, this is the leader. At least in Ethereum, you can even pick, you can say, Vitalik is a co-founder, or is even the founder. I can't even remember. I know Vitalik and somebody, one is co-founder, one is founder. You can even pick it up that, this is the founder of Ethereum. But even as the founder, Vitalik can't just wake up one day and say, this is where Ethereum will go. They're not born and where. It has to be a collective effort of all the organizations in the Ethereum ecosystem. For instance, the Ethereum Foundation, we have to vote. There are many, many other establishment organizations around the Ethereum. All of them will have to vote. This decision we want to take, they have to come in and vote. Are we voting for or against? Then, depending on the vote, that's when we now say where the organization or the next step the organization is going to take. So that's decentralized autonomous organizations. For instance, Bitcoin now, people only know Satoshi Nakamoto, but nobody knows him in real life. In fact, I was telling somebody, I said, this Satoshi guy is a very wise guy. If not, they would have killed him. Yeah, they would have killed him. But because right now you don't even know whether he's a person, whether it's an organization. From the name, you think he's a Japanese guy. Forget, he might not even be from Japan. Because Satoshi Nakamoto, that name sounds like a Japanese name. Like, let me even shock you. The person might not even be from Japan. It might not even be a single individual. It might be a group of people that come together and do the work and use that name just as a code name. Of course, because for everything that is to be published, it has to have a name so that you can say, okay, this is coming from here. You understand? So right now, the way the Bitcoin space is, you can't say this is the CEO or this is the leader. Say follow the leader. No. Anything they want to do, they have to come together, chain code, Bitrust, Bitshala, and all the organizations under Bitcoin. They have to come together, hold a vote. Everybody will vote. All right. You see here, they talk about allow token holders. So it means those guys that are holding Bitcoin in large stock, even Ethereum, those guys like Ethereum Foundation and the rest. So I don't really know much of Ethereum since I'm not really in the ecosystem, right? So they will come in, they will vote on whether they are to move forward with that decision or not. So that is decentralized autonomous organization. So any question before we move? My question is coming. Oh, I've been seeing Ruben clapping and Tech Explorer. Don't worry. All right. So, overview of smart contract platforms. All right. Now, this does not mean this is the only smart contract platform we have. There are numerous. If I to show you that we have more than 50 smart contract platform. It's only when you do research you know. I know the only ones you know is the one that has to do airdrop. And even me, the one I know very well is the one that has to do airdrop. Okay, so smart contract needs a blockchain to run, just like we said. A smart contract only or always runs on a blockchain. Now, here are some of the Ethereum. Of course, everybody knows Ethereum. And one thing is that Ethereum is the pioneer. Now, somebody might ask, but Bitcoin came before Ethereum. It's true. But Ethereum, Bitcoin is just a store of value. It's just like gold. You can't carry gold to the market now and say, okay, how much be your TV? Oh yeah, see gold. I want to buy your TV. I want to use your gold, my gold, buy your TV. Like the person will be looking at you that is this man okay? You understand? So gold is meant to be a store of value. It's something that you can pick, maybe you need to get a loan or something, you can use it as a collateral or something like that. It's just meant to be a store of value and not to be used for transactions and other utility. So that is where Ethereum came in. Ethereum came as a blockchain that you can use to build applications on top of it. Bitcoin, you can't build application on top of Bitcoin. You can only run transaction, but you can't build application on it. So that's why Ethereum is always the pioneer. And that's why I see Bitcoin is not among them, because you can't run a smart contract on Bitcoin. Yeah. All right. So Ethereum being the pioneer, it's like the app store for smart contracts, right? And it uses a language called Solidity. Now, we also have Solana or Aptos. Just like I said, there are others. There's Sui, there's Movement, like that. So Solana and Aptos, they are fast, very, very fast. And they're also cheap. In fact, I think Aptos gas fee is as low as $0.0001. It's very, very low. Yeah. So I think Solana too has the gas fee too is low, actually. So, and they use, like Solana makes use of Rust, while Aptos makes use of Move. So Stacknet, of course, I know majority of us on this call will likely have an idea of Stacknet. So Stacknet is like a layer 2 blockchain that runs smart contract too. So it makes it faster. So it helps to scale Ethereum. That's making it faster for you to run transaction on Ethereum. And also it makes use of Cairo as the programming language. All right. So that's why you see they say smart contract are code. And if you want to write a code, you have to write it in a particular language. So for Stacknet, you have Cairo. For Aptos, you have Move. For Solana, you have Rust. Of course, Solana also uses Python. They have a Python framework, but not many people make use of that Python framework. Majority of people I know, they prefer to use Rust. Why Ethereum, it uses Solidity. So any question? Okay. So now let's look at, we talked about smart contract, right? And we say smart contract is a code. So let's now look at, if it's a code, what is now the structure of that code? So this is actually an example, since I know the first class you people will be having is that of Solidity. That's why I decided to pick an example with Solidity. Even I would have picked maybe with Rust, since you guys will still do Rust, or with Cairo. But let me go with the first. So now, what you should watch out for in a smart contract is, number one, state variables. Now, these state variables are what store data. And why do they store data? They store data because data has to be remembered. Two, functions. Now, what does these functions do? They define behavior. They carry out action. And then finally, events. Now, what does events do? Events helps you to get information about the blockchain outside of the blockchain. It's just like they tell you, okay, the 36 states or the 36 states and all its governors are in a closed door meeting. Now it means that you don't have access to the information. But if like there's a journalist or there's a TV station that is live inside that meeting and broadcasting from that meeting, you see that you'll be able to know what they are discussing, despite the fact the meeting is a closed door meeting, but there's a feedback from the meeting to you that is not inside of that meeting. So that's what event does. So event just helps to notify those in the outside world of what is happening in the blockchain. All right. So every smart contract, we have an event. They'll have an event. So now, so this is actually an example of a smart contract. There you have contract hello world. So this contract now, this signifies the beginning of the contract, and the name of the contract here is hello world. This one is actually the version of the Solidity you are using, Pragma Solidity. This arrow facing up is trying to tell it that it should use from version 0.8.0 upwards. That's what it means. All right. So now, if this one is actually a string, is a variable that stores state. So in this case now, this variable message is storing hello world. and this string is a type of the variable. Why this public is to tell you that anybody can access this hello world. It's public. Any other function can access it. There's public, I think there's private. I can't really remember. Yeah. So now the next one is functions. They say functions define behavior. Now this is a function. And if you look at clearly, what is this function doing? This function is updating the state of this variable. Now in this state, this variable is storing hello world. So in this state, message variable message is hello world. But this function is updating that state, is accepting a new message, right? And is updating this existing variable with hello world, is updating it to whatsoever thing you pass into this function. The only thing that is lacking here is actually the event. So forgive me for that. But just take note of these three. These are the structure of a smart contract: state variables, functions, events. So any question before we move forward?
I have a question. Sir, please, sorry for
Okay,
drawing back. Please,
no problem.
what are the differences between smart contract on Ethereum and Solana? Like the differences of smart contract between this Ethereum and Solana.
The truth is that there's no difference. The only difference is number one, the platform, which is the blockchain itself, because the platform, the blockchain is the platform on which smart contract runs. So the difference is just the platform, their design, their architectural design. So you can see the architectural design of Ethereum. They do it in such a way, once the network is congested, gas fee will be high. And that's why you have so many other layer 2 platform running on the Ethereum to make it cheaper, to make it scalable. For the Solana is also a platform. And based on the architecture, no matter how transaction is, your gas fee will always be low. But that does not mean the gas fee does not increase too. When there's congestion, that's when many people are trying to perform transaction on it. The gas fee too increases, but not as much as Ethereum. I think, okay, was it in this class? Okay, not in this class. I was telling my student that there was one time I got $125 like that. For me to withdraw $25, Ethereum are telling me they have to pay 6 point something dollar. You understand? Why? At that point in time, the network is congested. There are many people that are trying to run transactions on the Ethereum, and that is very, very expensive. All right. If it were to be on Solana or Aptos, that $25, the only thing they will charge me, they might end up charging me $0.001. If it's worst, they charge me $0.1. So compare $0.1 to $6. You understand? So do you get it now? So the difference is in the platform and their architecture. So the architecture will now determine what programming language you will use to build on it. So any other question? Do you get it now? Do you understand?
Yeah. Okay. So, thank you for this one. But so what are the challenges of smart contract behavior? Like some of the challenges we like
Don't
that we are
worry.
meant to know.
We'll get there. Let me show you. Look at it. Risks and what? Limitations. So we'll get there. But it's a good question. Yeah, very good one. All right. So because everything that has an advantage has a disadvantage. That's why they tell you not all that glitters is gold. Not that what glitters, things that glitters are bad, but just trying to tell you that it's not all aspect of things that shine that are actually good. They can always be like a shortcoming or a disadvantage to it. So gas fee and scalability. So let's look at, because there's no how you talk about smart contract that you don't talk about gas fee. I don't talk about scalability. Why are we talking about scalability? Remember, they say smart contract cannot be changed, but it can always be upgraded. So for you to be able to upgrade something, it means that thing have to be scalable. You can't upgrade what is not scalable. And then we talked a little about gas fee, where it's more like an incentive that is being paid to validators and to miners. All right. So every smart, okay, before I go, let me talk about something. I talked about once a network is congested, right? Once there are many transactions running on a network, the gas fee is likely to increase. Now, the reason being that there's what they call, I've forgotten at this point, but at any point in time I remember, I'll let you know, right? Now, what is happening is that once there are many people trying to run transaction, everybody is trying to push for his transaction to be validated by the validators. So some almost blockchain, they permit something in that the higher fee you pay as gas fee, all right, the more validators will likely validate your transaction on time compared to those paying lesser fee. I don't know if you get. If we have 10 people, right? 1, 2, 3, 4, 5, 6 till 10. And then all 10 are trying to run a transaction immediately. And we are having just like maybe 4 validators for the 10 people. Those 4 validators will likely prioritize those with higher gas fee than others. Why? Because they know that higher gas fee simply means more money to them. And of course, there's no validator that you tell me that is running a node because of charity. Every validator is out there to make profit. So they'll rather go for those ones that are having higher gas fee and all of that. So that's why normally at such, what the network does is that most especially those ones that automatically calculate gas fee for you. So what they do is that they automatically calculate it to the price point where they feel at that point you can easily get a validator to validate your transaction immediately instead of waiting for hours or waiting for some time. So I don't know if you guys understand. Okay. So thank you. Okay, somebody wants to ask a question? Oche, you're raising up your hand. Or is it that is that hand that have been up since?
No,
Okay, so go on. I'm listening.
I wanted to ask that why is it that for like they usually suggest that if you want to receive funds, that it's better to go through Trust Wallet rather than Binance and KuCoin
Okay, good.
because they can block your accounts due to something if they notice any like fraudulent activity or something like that.
Yes. So now, why they always advise you to go through Trust is because wallet like Trust, MetaMask, they are decentralized. What it means by decentralized is that they only give you access to your account that is on the blockchain. They don't manage anything for you. You understand? So Trust Wallet can come and block you. MetaMask can block you because what they are doing is that they are like creating a path for you to access your funds that is on the blockchain directly. But what the Binance, Bybit, BitGet, and all those centralized exchange do is that you open an account with them. They are the ones managing your funds. So if tomorrow they come and say Bybit owner have died, the CEO have died, blah 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 blah, this one, the platform, like they can't access what they need to access to be able to run the platform. It means your money is gone. Because all the money that you have inside Bybit is with them. It's not for you. It's for them, technically. They are keeping it for you. And anybody that is keeping something for you is for the person. Because if the person decides to go with it, what will you do? Eh? I think I've heard where people lost millions of naira to centralized exchanges. Why? Because the exchanges folded up. There's one they had then. I've forgotten the guy's name. There's a case they had. Funny enough, the guy was supposed to go to prison. He did. They did not take him to prison. You understand? He took how many billions of dollars? People lost money. I know somebody personally that lost. The guy, that guy even have a strong heart. Even as some people, they feel no recover that kind of loss. So that's why they always advise you not to keep your money in centralized exchange because they can come and fold up at any point in time. They can decide to ban you and block your account. What will you do? All your money in your account is except maybe the centralized exchange, they are good enough or they are kind enough to like, okay, please transfer your funds. Or even after blocking, they'll give you an opportunity window to transfer your funds from your wallet. I know this particular world we are now, the god of this world is like money. So they have more money than you. So if you say you want to go to court, how much you get? Where you want to go court? So that's it. All right. So does that answer your question?
Yes, thank you.
You're welcome. All right. So quickly, let's look at gas fee and scalability. So every smart contract execution costs gas fees paid in cryptocurrency. Why you see they were specific that paid in cryptocurrency is that if you are running anything on the Ethereum blockchain and you want to transact in Ethereum, the gas fee you'll be paying will be in Ethereum and not in another currency. If you are running anything on the Ethereum blockchain and it's in USDT, the gas fee you'll be paying will be in USDT. If I say USDT, I think it will still be in Ethereum also. So that's why I see they say paid in cryptocurrency. You can't come and say, I have Naira, make I pay you this gas fee with Naira and make my transaction go. No, it will not work out. All right. So blockchains like Ethereum fees can be high due to congestion. I think we talked about this already. When the network gets busy, I talked about it, where you have so many people trying to run a transaction on the network. And as a result of this, we have layer 2 solutions. I think I spoke about this too. That's why we have layer 2 to scale Ethereum. And that's to help in the reduction of gas fee and all of that. So for example, you have Polygon, you have Stacknet. There should be a comma here. Sorry, it's a mistake. Stacknet, you have Polygon, you have Lisk. And all of this, their aim is to reduce the cost of this gas fee. Sometimes you can want to transfer $40 and Ethereum will tell you your gas fee is $10. Yeah, so imagine. Maybe to another country, $10 might not be much. It's just an 1 hour wage. But imagine you in Nigeria, you have to withdraw $40. They tell you that your gas fee is $10. so let's look at, so these are some of the actually risks that are there. Your gas fee, and due to high transaction, your gas fee can be high. But thank God for layer 2 solutions. That's why most people that transact now, you see them either transacting with Polygon, with Lisk. You hardly see somebody transacting directly with Ethereum, except maybe it's the Ethereum token it's sending. But if it's like a derivative, like USDT, USDC, you find more people sending USDT and USDT through Polygon, through Lisk, through BSC. That's Binance network and all of that. So now let's look at security risk in smart contracts, right? It says since smart contracts are immutable, remember we said it cannot be changed. It means if there is a bug, it cannot be fixed, at least not easily. Now, why can the bug be fixed? The bug can be fixed because the smart contract can be upgraded. So in the upgraded version, they can upgrade it and then fix that bug in the upgraded version. But of course, upgrading a smart contract too is not easy. All right, that's why I see here, they say it can't be fixed easily, not that it cannot be fixed. It can be fixed, but not easily. All right, so and then there are also other common security issues, which is what? Reentrancy attacks. They call it reentrancy attacks. So what is this reentrancy attacks? Is when a smart contract keeps repeating a call even after completing the operation. Let's say the smart contract is supposed to pay you $30 just once. Maybe for doing a particular task, it's supposed to pay you just $30 once, and that's all. But now, after paying you that $30, the function keeps on running and keeps on paying you $30, $30, $30. So that's one of the security issues of smart contract. There can be a reentrancy attacks where contract repeatedly call itself before completing previous operations. So it's synonymous to probably a thief tricking an ATM to give him money over again before it updates his balance. You understand? So this is one of the security issues. Another issue is logic flaws. So when you write a poor smart contract that doesn't check, contract that is just right, that contract can be exploited. So a tiny mistake in your smart contract, it can even lead to a point that you write a contract that lock a money in a safe, and you forget to write a contract to be able to receive that money, to collect or retrieve that money back from the safe. That's all. That's all. So any money that goes to that safe is locked forever. There's nothing you can do about it. So that's why even logic flaws, that's from your own end as a developer, you can have that issue. Another one is private key leaks. Now, once a private key is being leaked. That's that amount or whatever funds that is in that account can be stolen. So that's another risk of smart contracts. So if your smart contract is you making use of private key or is importing private key to run some activities, you have to make sure is doing it in such a way that even if a hacker decide to hack into the network, he will not be able to retrieve it. So the last one is immutable code. Now we've talked about this four. This number 4 is the same thing with this one that we started. Since smart contract are immutable. So once it's on the blockchain, once you do a smart contract, there's a bug. Once you upload it already, you can't do anything about it unless you upgrade it. And just like I said, upgrading is not like you going to a shop and buying lollipop. Say, madam, or the lollipop, 100 naira, no be 50, no, 100. Oh, yeah, give me one. It's not like that. It might take some time. And you know, those hackers, they are very fast. A hacker will not need a whole 24 hours. Some of their hacking is instantaneous. Within 5 minutes, they have drained you. So you can't use 5 minutes to upgrade a smart contract because you need to go check where the issue is, fix it, redeploy it, and all of those things. Before on test net, you check whether it's working the way it's supposed to work before you now deploy it to the main net. So a hacker does not need that much time to do whatsoever thing he wants to do. All right. So these are some of the security risks. And if you check, I will advise you to go and check. You find out that there are also some major hacks that they have done in history due to some of these things. And those major hacks, some of them runs in millions of dollars, $60 million. Imagine they give you $60 million now. If you like, say, no work from now until you die. But that's what it is. All right. So now, okay, somebody might ask, how do we now protect ourselves against this? Number one is you make sure you don't write poor contracts. You pay attention to the contract you are writing. 2, once you have written your contract, you make sure you get at least 2 to 3 because that one too cost money, but at least it's better. You understand? You take 2 to 3 people that will check your code. There are organizations that are dedicated to that. They check your code for any form of exploit and all of that. Some test your code to see how strong it is against malicious attacks. So there are organizations like that. They have the skill, they have the manpower, and they have the resources to carry out those kind of attacks on your code, to test it and make sure it's robust enough. All right. So that's it. So key takeaways, of course, these are the major things we discuss. Smart contract are automatic, truthless, and unchangeable agreements on a blockchain. They are self-executing programs on the blockchain. 2, they cut out middlemen and speed up processes in areas like finance, art, and organizations. They automate transactions, eliminating middlemen. We talked about these 2. Risks include high gas fee, security vulnerabilities, and immutability. So at this point, are there any questions before we start our discussion?
Okay, so there are no tools or any auditing tools or securing tools for securing the like smart contracts. Are there any tools?
There are tools, right? Yes, thank you for that word. I was looking for the word, but I don't know. It escaped my mind. Auditing. So they're auditing companies. They are auditing tools, right? But you can't compare you using, when you talk of tool is not like a standalone something. It's something that should aid the work of a professional, right? Let's say, for instance, now you carry ChatGPT, say, ChatGPT can code, ChatGPT can code. You don't carry ChatGPT and go and give somebody that don't even know what loop is. He don't even know what conditional statement is. You don't give him that guy, use this to code. You have to kill the person now. You understand? So in as much as tools are there to make your work easy, you can compare it to when a professional makes use of that tool. So that's why it's still good to go through an auditing company. You understand? Because in as much as the tools are there, the auditing company will make use of the tool and their years of experience. And it will even shock you that they can even extend it to using their networks. That's what I mean by networks. Let's say I'm an auditor. There's a high possibility I have another auditor in another company. After auditing the code, I might chat up my fellow friend that's also an auditor and say, guy, how far? There's this code I'm auditing, but I'm feeling I've not done enough. How far? Is there any way I can audit this thing that is different from the way we are doing it? He might look at it and say, yes, the tool we are using for auditing is quite different from yours. I can give him the code and say, please, let me check through this code. You understand? So, and a fellow professional auditor can also leverage knowledge of other auditors and apply it to your work and make sure your code is properly vetted and audited. You understand? And some of them, or most of them, they even offer professional advice. That's after auditing your code. If they find out some vulnerabilities in the code, some of them can even offer the service of fixing it or advising you on how to fix it. Or if it involves an entire change in the infrastructure of your smart contract, they will advise you on, this issue you are having is as a result of this infrastructure, and not infrastructure in this case, is as a result of the way the pattern of your coding. Can you change it to so pattern? Why? Through years of experience, they have come across different code that have implemented that, and I've seen that code will always be open for that kind of exploit or error, and then they'll give you a professional advice to change it and all of that. So that's some of the key benefits. All right. So any other question? I'm just happy.
Hi, sir.
Okay.
So yesterday we talked about encryption and cryptography. So I want
Yes.
to ask, what type of cryptography, or I don't know what I'll say, maybe what type of encryption does zero knowledge use?
Okay. Now that's why they call it zero knowledge. You are not supposed to know it. You, the user, you are not supposed to know it. All right. So I don't know. There are actually different form and kinds of encryption. Even you can come up with your own kind of encryption if you like. So it depends on the company, because different companies are offering different zero knowledge proofs. For instance, Stackware is a company that is heavy on zero knowledge proofs, and they do it for Stacknet. They do it for other companies. You understand? So there are also other companies that deals with zero knowledge proofs and all of that. You understand? Where it helps you verify, but you don't need to know the content of that thing. So I think there's no really one particular encryption style. And they can even pick an existing encryption style, remodify it, or add something on top to make it robust. Do you get? Do you understand?
Yes, sir.
Okay. So
So
somebody is raising.
you were mentioning something about increasing gas fee to make transactions faster on the
Yes.
blockchain, and you
Yes.
couldn't get a hold of the words that you wanted to use. So I was able to check, and I saw it was GUI. I think GWEI.
Okay. And that GWEN, is it GWEN?
GWEI.
And that GUI, that GWEI, is a unit of Ethereum. Now, every blockchain has their own cryptocurrency, and every cryptocurrency has a unit. Like the unit of Naira is Kobo, the unit of dollar is cent. You understand? So the unit of Ethereum, ETH is GUI. The unit of Bitcoin, BTC. Who can tell me the unit
Sat,
of Bitcoin?
sat.
Sat, beautiful. The full name is Satoshi's, right? But it's Sat. So that GUI is actually there's a name for it, I've forgotten. I was reading it. There's a Bitcoin course I did, and they spoke about it, where it gives you the opportunity to increase your gas fee so that validators will attend to your transaction more quicker than others. Well, if I remember, I'll let you know. But you can do a search on it. I believe you get it.
I think it's priority fee on the
So thank you for that. So take notes, priority fee. So somebody is raising up his hand. Please go on.
Yes, sir. My question is on the smart contract. Just like how we say is a line of code which are self-executed. So I want to ask, if we want to generate this smart contract to perform a particular tax.
Yes.
How do we write this contract, and what are the platforms or the tools we can use to do this contract, or how are these contracts being created on the blockchain and saved?
Okay. So, right. Don't worry. We have not gotten to that part. Of course, I'm not even the person taking that part, but let me just talk a little about it. All right. So now, if you write a smart contract, how most blockchain works is that you write a smart contract. Now, some chains have DevNet, testnet, and mainnet. Let's forget about DevNet. So testnet and mainnet. Now, a testnet is a direct replica of mainnet. The only difference is that you don't use real money or real coins on a testnet. You use what they call sepolia. It does not have value. All right. So any smart contract you write that is doing a particular thing, of course, you must have checking which platform do I want to write this smart contract. Okay, I want to write it on Aptos. Okay, which programming language does Aptos make use of? Oh, sorry, let's use Stacknet in this case. Which blockchain do I want to write this smart contract on? I want to write it on Stacknet. Okay, which programming language is Stacknet using, or does Stacknet use? Stacknet makes use of what? Cairo programming language. Okay, so now you now write that contract in Cairo. Then after you write it, there's what they call deployment. You now deploy that smart contract to the test net. Then you now do all the checks you want to do. If that contract you wrote is really doing or executing the actions it was supposed to execute based on the input you are supplying it, based on your design. If you feel it meets to your design, to your standard and all of that, then you can now start talking about deploying it to what? Your main net. So these are the stages involved. You check the blockchain, you check which programming language is used on the blockchain. Now, something like Solana makes use of Rust, but don't go and think you see pure Rust in Solana. Even the Rust Solana uses makes use of what? It makes use of a framework-like system. The same thing with Stacknet. Stacknet makes use of Cairo, but Stacknet does not use the pure Cairo that you know. The pure Cairo that you know does not have state. You see the state, it does not have it. It cannot store state. But now, Stacknet now made it in such a way, they build like a framework-like system using Cairo. And at that, they now include a storage that will be able to manage state to meet up to the structure of a smart contract. So I don't know if you are getting what I'm saying, or you understand what I said.
Yes, sir. Yes, sir. I'm getting you. Yeah.
Okay. So any other question? All of now, I know what we could discuss. Okay. Now, only when I just they learn. When I no fit, me ma go learn, Nana. So any other question before we start holding our interactive sections? I know me, I love interaction very well because I know I get to learn a lot. So okay. So what do you guys say? Should we start from that yesterday's topic and discuss on it before coming to today's own, or we should discuss today's own first before moving to yesterday's own? So I need your opinion on that.
Next to me, I think we should discuss from yesterday.
Okay,
So,
from yesterday. Okay. All right. So let me do that.
Please, can we have a link for this today's slides?
Definitely. I'm thinking they must have sent it to you guys. I don't know.
And sir, please, the slide that they sent for us, we cannot download it. Maybe for those of us that wants to be reading, maybe offline or have it
Offline.
on our,
Okay.
yeah. We were not
No,
able to download it. It's just showing like a full how will I call it, slideshow.
Okay, I get. And no problem. They will send it hopefully today as a PDF copy so that you'll be able to have access to it. All right. So now we talked about. So let's look at least you guys have done this first challenge. You guys say you should hash your name and share the results, right? I've gone through the chat and then I saw a couple of people's hashing that they hash their name, right? You can copy this name and go and put it in your LinkedIn. Oh, you say my hashed name. Eh? All right, just joking though, Sha. So now, how does cryptography ensure security in blockchain? Like, let's discuss. How do you think cryptography ensures security in blockchain? What aspect of security does it deals with? Hmm? So everybody is quiet like
Let,
this.
let me just see. Let me just try.
Okay.
When we are talking about cryptography, you mentioned about there's a place we said about data integrity and non and data integrity. That is
Yes.
using of hash function is related to cryptography. So with the use of hash function, blockchain uses cryptography hash function like that to ensure data integrity. So with that hash function,
Yes.
data can be have integrity, and when blocks is created, the
Yes.
content are hashed into a fixed length of string. So
Mm.
any change in the yes, so the content. I hear what I'm saying.
Yes, I'm hearing. I'm hearing.
So any change in the data will completely make difference in the hashes and make it easy to detect the tampering that someone tampered with it.
Good. 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 I love that. I love that. So, any other person? Wait, do we have ladies on this call? Let me see. Are there ladies ever at all? Please, if there are ladies, call them out. Oh. After now, they'll be dragging trouser with boys. That's what a man can do. A woman can do better. Christiana, don't run. Oh, better come back. Eh?
She don't run.
She don't run. Imagine. And they go dey drag trouser with us. Oh, trouser who they manage. They go see dragon. Say they fit do am better. Now, make them come show themselves. They run. Hmm? Well, ladies, oh, all these while the men that have been speaking, and I'm seeing plenty ladies here. Look at Ifeloju, look at Latifat, look at Gloria, look at Farida, look at Christiana. Hey, I beg, more than no shame me. Oh. Hmm? No mind them. Oh. Text is no one talk. Okay, so any other person? Or should we
Okay,
move to
can
the
I
next one?
let me
I
just put
think
in something from
okay.
what the previous person said.
Okay,
So I'm going to talk about the hashing and the encryption part.
okay.
So for the hash functions, the way the cryptography helps us, it is, let's take for instance in our Bitcoin when we want to send money, we have already gotten a generated hash. So any
Yes.
change in any transaction in a block, it is
Mm,
going to require calculating all the hashes of
mm,
previous blocks, which
blocks.
is very, very, how would I say it, computationally
Impossible.
difficult.
Mm,
So it's kind of gives us the edge over a breach of integrity.
mm,
So moving to the security part, ensuring the digital signatures for us to be able to sign the encryption that gives us the edge to sign with our private keys, like what you just mentioned of the wallet connect your wallet
mm,
to approve a transaction and other stuff. So just those 2 cents that I just wanted to add.
mm. Beautiful. I love that. So, Tech
Okay.
Explorer, you want to say
Let
something?
me. Yeah, there's something. Like last week, we taught about consensus mechanism is also a features whereby like the proof of works and proof of stake leverage the cryptographic features in order to secure the blockchain, that kind of a thing.
Mm-hmm. Beautiful. Thank you for that. So, John, please go on.
Okay. And it also ensures security by using the asymmetric encryption, whereas it uses two key pairs. That's the public and private key
Private
to
key.
secure. Yes. And also helps tackles reverse engineering, whereas hashed transaction can be reversed.
Awesome. Awesome. I love this. I love this class. My God. Please, how can I join you people? Can somebody send me the link? I want to apply. It's paying me that I did not apply. Kai. I need to join this class. It's not only people that will be enjoying. Okay, so let's.
So we are praying to be like you, so we also teach other people if you want to join.
Me, I want to learn like you people. Like this. I'm praying that I should be learning like you people like this. Okay. So thank you. So let's look at the second
Yes,
discussion.
I just want to add on what Sandy John said. Like, is a value pair of keys, which is asymmetric, as he said. So, taking the context of the asymmetric encryption and decryption makes it more secure. I think that's where the public and the private key, one needs to decode the other for it to work, not in the symmetric pattern. So that's what makes it so secure in blockchain.
Okay, beautiful.
The keys.
Beautiful. I love this. So the second question, the second group discussion says, why is a private key critical to protecting digital assets? Like, why is it critical? Or in another words, what is the importance of private key in protecting digital assets? Or how does it protect digital assets?
Can I go?
Yes, please go, Michael.
Okay. A private key is a unanimous key that only you has access to. Let's take for instance, you have a mailbox outside that has a key lock. You give a key to the mailman that whenever he decides to drop the mail, he should open this part of the box and drop the mail. And that part of the box has a very, very small hole that even someone's hand cannot pass through it. Only the mail that can pass through it. So when you want to retrieve this mail that the mailman has posted into your mailbox, you have your own private key in which you can use to unlock the bigger part of the mailbox where you retrieve your mail. So that's just how the private key is critical for the digital assets.
I like this example you gave. Okay, so Joel, go on. Can you?
Okay, it's important in the sense that a private key is a personally owned key that you can only use, that you alone can use to access your digital assets. Like unless it's given outside to anybody, you alone own that key, and it's very important because once it's lost, there's no way you can access that data again. It is personally owned. That's what I just had to say.
I love this.
Yeah.
I love this. Farida, I'm happy. The first female speaking. Please, we should put it on record. Tuesday, 18th March. Farida, first female to speak. So please go on, Farida. Don't run, no.
Am I audible?
Yes, you are.
So I think not just is it like very vital in security wise, because like it protects your assets from potential thieves, but also it serves as kind of like the proof of ownership, because if you have like the key, it's like basically like the first person that explained it. It's like you have the access, you're the only one that can access it because those keys are what you have what can help you to access your information. So if you lose it, you cannot access your information. So it serves kind of like a proof of ownership and also as a form of security as well.
I love this. Proof of ownership, security. That's good. Please go on.
Yeah, so the private key is just like an authorization in the sense that only the owner can use it to authorize any transaction, any thing that want, any tax that want to be performed on the wallet.
Beautiful. Beautiful.
Okay, let's pick like a 5-year-old private key from the name personal key and digital asset, my money. A key that only one person can own to unlock his own personal asset. So private key is just personal key.
Awesome. Wow. I'm impressed. I love this class. So because actually this is what we did yesterday. So normally the human mind normally forgets things, but I'm impressed. Shows you guys are really following. I love this. So let's look at the third one. Say, how does hashing helps prevent fraud in blockchain? Good. Also compared to the ATM pin, exactly. So how does hashing help prevent fraud in blockchain? So anybody? Okay, please go on, Joel.
Just like you stated yesterday, like what you said, hashing helps you with security in the sense that there is no, okay, like somebody also said, there is no reversible transaction that can be done. Also, like you said, is it always ensures that the transaction keeps moving forward, so there's no backward movement. So any slight change, the hash key changes. So nobody can go back and tamper with a particular transaction. So
Okay.
yes.
Beautiful. Okay, please go on. Adi.
Okay, just like Joel said, the hashing just help you. It's just like it helps you detect to verify like if it has not been tampered with. Just like the example we did then. Then when we deleted the dot, it changes the hash. So let's say, for example, someone send that hash to us, and then you try to like use the public key. You can be able to detect or verify if that particular transaction has been altered along the way or not.
Or not. Exactly. I love this.
Okay,
Tech
hashing.
Explorer.
Okay.
And go on. Go on.
Okay, hashing helps us to connect between one block to the other, as we all know. So in every transaction that is in each block, if you want to alter, we know that it is immutable. So that immutability gives it more security and prevents people from tampering with what is in the transaction. So hashing connects one block to the other. So it is very vital, and you cannot touch any block without altering the other one. So it gives
the other one. Awesome. Awesome.
So, sir, you see them like in a digital transaction when you were teaching that um a transaction a transaction when it's being done in the blockchain, it must be signed by the sender using a private key.
Yes.
Using a private key. So the transaction of that data is hashed and then signed, because for you to sign the data, you must hash it and then sign it before it will like play its function by
Yes.
implementing the transaction.
Yes. Exactly. Exactly. So I love this class. This is beautiful. This is lovely. All right. So you guys all answered beautifully. Okay, Michael, go on.
So my question is this. Let's take,
Yes.
for instance, someone wants to implement blockchain technology into their business. Okay,
Yes.
let's say the person is a farmer. He has some produce that he wants to sell. He wants to be able to track this produce from farmer. So he is quite familiar with cryptocurrency. And you
Okay.
know, most of these farmers in Nigeria, they don't have knowledge of cryptocurrency and the likes. So
Yes.
how can we implement, or how can this technology be implemented that they can use fiat for it? I don't know if you get
Okay.
my point.
Yes. Yes. I get your point. I get your
Because not
point.
everybody may want to get a cryptocurrency to be spending on, because explaining it to them is very, very stressing and stressful.
Yeah. You're right, actually. There's one thing I was talking to a friend yesterday, right? Ayo Media, and then I was trying to tell him that I don't know why, but blockchain just makes things over technical and over complicated. Now, it's not as if they can't make it simpler, you understand? But it's just how technical people work. You know, it's just like you now, if somebody comes to you and say he's trying to learn ABCD, you might not be able to relate to the person because, guy, waiting the ABCD. What in the there now? But do you remember that plenty things they there when you are learning it when you are in nursery? In fact, sometimes from ABC you move to W. All right. So I was not telling you that blockchain just make things unnecessary by bringing in some kind of words, something they'll just put in plain language. But all this one is just in a bit to try to differentiate them from Web 2, right? They don't want an event where instead of saying ledger, because ledger is an English word that is synonymous with the bank, the accounting people, the accounting bank and the rest. Instead of them to just say a public ledger, they say blockchain. So so you can imagine. So me, I feel the way we can actually introduce products that is built on blockchain to some of these traditional people and local people that have no knowledge of it is to abstract a lot of things that have to do with the technical aspect of blockchain, right? You can do it in such a way that everything is automated. The application has an in-app wallet that once they are sending money or once they want to buy airtime, the transaction will run behind the scene depending on what they want. Is it 100 naira airtime? They put their phone number and then they go ahead and process it. All the processing will be done beneath. They don't really need to do much. You understand? So I feel that's from my own point of view. Of course, everybody has his own point of view, but I think this is even part of the discussion we are going to do for our second class. All right. So let me just stop here. So I feel the best way is just to make sure we just uh, like anything that will make it too complex for them, we just find a way to abstract it. Abstraction. Like if all of us were to be coding in the real language of computer, even me, I'm not sure I would do programming. Maybe I would have been doing farming work. I know Jethro have plenty land. So Jethro, I'll come and collect land. I'll be doing farming work. If we were to be coding in real language of computers, which is assembly. Have you tried to see what assembly language is? You don't even know. Yes, you might have an idea of what is happening, but my brother is a lot. So all this JavaScript, TypeScript, Rust, C is an abstraction. You understand? Imagine you trying to write your name and you have to convert everything to 00110. You don't even, you understand? So all these JavaScript is an abstraction to all those things because at the end of the day, all of those Rust, C, C sharp, sharp, C++, they still compile to assembly language, and the assembly language compile to binary. You understand? So one way is to abstract as much as we can. And thank God you guys will be learning Xion blockchain. So Xion blockchain is an abstracted kind of blockchain. So I believe you get to understand more of that. Yeah. So any question before we actually go to the discussion for today, for today's topic? Okay, no question. So but I hope we're enjoying the class. I hope we're understanding because that's the most important thing. Understanding. Okay. Okay. Okay, please go on, Oche. Can see you are raising up your hand. Oche, go on.
I said, can we have access to the PowerPoint, or is it PDF you are using?
Yes, definitely. It's for you guys. It's not for me.
Because we do not see it though.
Okay, they'll send it to you guys. But I think they send it to
Alright.
the Discord China. I think they did that.
Okay.
But
So
they'll
the
send
one
it.
that was sent to the Discord, well, I think it was yesterday's own.
Okay, they'll send today's own to you guys as well.
Okay.
Yeah, your sub
Maybe you
mentors
tell
are.
please help us and send it to, because I was not around for the other class.
Oh, yeah,
So I'll
they'll send
just
it.
go through it. All right.
Yeah, they'll send it. So today's discussion. Now, the first one, what could smart contract do? Share your thoughts. So what do you think smart contract can do? Can smart contract help you to go and fetch water? It's a smart contract. Fetch 1 cup of water for me. Make sure the water is cold and bring it. So
It
what do you
cannot.
think smart contract can do? It
It
cannot.
only
Okay.
works. It only works in the digital space.
Okay. I love
Just
this.
like an example, all these automated gates. Your gate, instead of having gates man, you
Yes.
just go to the house by so time. Lock the gate by so time. When I'm leaving the house, lock it. When I press my horn in my car, open the gate. All those kind of things. Until it's just for it to meet some certain conditions, so that it can run.
Beautiful. I love this. So what could smart contract do? Can somebody share? What do you think it can do? Like from what you have seen, what they are. What other possibilities do you think? Okay, please go on, Christiana. Or is it Christian? Hope I'm not.
Can you hear me? Can you all hear me?
Yes, we can hear you. Well, if you can be more audible, right?
Okay, I wanted to ask a question as regards the first question you asked. You said,
okay,
can smart contracts can you tell your smart contract to go and fetch water and to go and fetch water? So now my question is that since you cannot tell your smart contract to go and fetch water, can you integrate smart contracts maybe with AI to go and fetch your water for you? Maybe with a bot or something. I don't know. Is it possible that they can merge the three together? Smart contracts, artificial intelligence, and a robot or something to do that? Is it possible?
Yes, it is. In fact, I think that's even where some of these blockchain are targeting right now. They are targeting the space of AI, right? They are looking for those that will build applications that will bridge AI and blockchain together. And the reason why they are looking towards that is that imagine you go to a company to buy a robot. How sure are you that that robot does not still have, that company does not still have control over that robot that you have bought? They are the ones that design it. Obviously, you might not be an engineer or you might not have enough knowledge to understand all the components inside. So that is where blockchain comes in, all right? Where you are running it. If it's an AI that makes use of network, you are running it through the blockchain network, and you are sure that given that it's on the blockchain network, nobody can come and intercept the robots. Nobody can come and check through the network. It will check and see, so now so these bros now so they sleep, they throw leg, they snore. And then one day you want to run for president, you see one video, say your president is an irresponsible, your president to be is an irresponsible, snoring young man. You understand? So due to all those security concerns, so blockchain have been looking at with intern interest on how to breach this. So it's actually a possibility, Christiana. Not that me I can build it all. For you say, like say that our teacher and hot cake, that
Okay,
code cake.
Sorry, but is he on ground right now? Like, is he on ground?
Right now, I don't think there's something like that. There is AI plus blockchain. But I don't think there's AI plus blockchain plus hardware. You know, robot is a hardware.
Yes.
So I don't think there's anything like that. At least according to my knowledge, I might be wrong, of course. 'Cause I don't have knowledge to everything. So, but if you are thinking of building something like that, I'm rooting for you. You should build it.
Thank you.
Yeah, you're welcome. So, Farida, your hand is up.
I think the question is concerning how smart contracts can be used in our daily lives, right?
Yes.
So I was thinking, like one of our major issues here in Nigeria, it can be used in like voting systems, like to conduct like more secure and like the how the voting systems will be less tampered with. In my I think that it can be used in like systems like that, and also like maybe in like healthcare aspect and so for like securely maybe with patient records. How when you're in a hospital, like most of the information as a patient is supposed to be like very closed off. It's supposed to be very secure. You're not supposed to share those information with other people, but like you'd still see information being shared. So like I think it can also be used in like situations like that as well, or like paying basically.
I love this. Most especially you see that voting system. Imagine the middle of the night, INEC offering IRF. If na blockchain, they no burn them well. I don't want to off blockchain. They don't off
Exactly.
blockchain. Yeah, you understand?
Yeah.
Because they are not in control of it. So it's true. And also for patients' record, keeping patients' record confidential.
Yeah.
You're right. So please go on.
I want to say, like, smart contracts, as I'm seeing it, can automatically, like, it can do payment automatically without, like, when the conditions of the payment is being met in the smart contracts. It can automatically, like, paying of rent and subscription automatically without the person, as far as the person made the reoccurrence of that payment. That's
Awesome.
everything.
Okay. You are right. In fact, I saw a product where some group of persons are building airtime, right? All this airtime and data app. But this time around, make use of blockchain. So you are right. So please go on. The person raising up his hand.
I wanted to talk about in some kind of finance industries. It actually answers the two questions, the first and the second one. In the finance aspects, let's take for instance insurance policies, insurance companies. Okay, if you have your premium that gets up to a certain amount, let's say 3 million naira, for example, then they can start paying you let's say like 2% of it monthly. And also if you have some kind of disasters like climate that causes hurricane, that causes fire outbreak, or maybe your car has issues, or you have an accident on the highway, all those kind of things can automatically, smart contracts can automatically trigger a payment.
You are right. In fact, as you are speaking, most especially you see that what are they calling it? That what are they calling this retirement, that pension, right? You find out that most especially in this country, a lot of people face so many difficulty with pension. You see those that stopped working with the government, they retired, and then for 5 years they have not paid them anything. They'll tell you they are still processing their pension. If it were to be blockchain, based on the agreement, once you have stopped working, maybe they can decide to, after a year, you start receiving a pension. You find out that it kicks off automatically. But since now it's in the control of the government can come out and claim to you that they don't have the money to pay. And there's nothing you can do about it as a citizen. All right. So you're actually right. Yes. And even in all those companies, insurance companies or life assurance company, where probably by the time your money gets to a particular point, they will start paying you some amount of money. Some of those insurance companies don't do that. And you can't take them to court. Because just like I say, money is the God of this world. When I mean God, I don't mean capital letter G. I don't mean the main Allah or the main God. I mean small letter G, the person that is running things. You understand? And those companies have the connection, the government connection, they have the money. So taking them to court is like absolutely waste, most especially in a corrupt system. Yeah. So you're actually right. I love this. I love this. So Farida, please go on.
I actually have an addition to what Michael mentioned. I think it can also be used in employer-employee contracts as well. Because like most of the time when you have all these like employer contracts, they start working and then after a while you're supposed to increase, or after like a promotion, let's say you're supposed to increase this much amount of money to their payments. But like because it's a human contract, you'd find out that like most of the time it will take like a year before the increment of salaries is implemented, or like a breach in contract whereby you're maybe let's take this NYSC for instance. Like they're supposed to start paying the corpers like 77,000 according to what the government have mentioned. But like it's been like I think 2 months and then like nothing has been seen. So like I think it can be used in systems like this where whenever a rule is passed, it can be automatically synced everywhere, and then all people that are affected by the payments or anything, employer-employee relationship basically, can get their money and then paid and just away with it.
I love this. The way Michael is so interested when Farida is talking, it's as if he's a copper. Michael, copper, we.
I'm not a copper, but what she said is actually very, very right. There's no doubt about that. But if you as a person, you are looking to develop a product and you are targeting the federal government, I'm very, very sure you are going to sleep there. Because they are actually scams. Before they even take you serious to implement that your idea, it may take years for it to be implemented. And for the fact that
it because it would affect them negatively. That's the whole point. It's more of like a system, a corruption-based thing, more
exactly.
Yeah, so they won't really implement something like that because it won't deepen their pockets. So
for the fact that they know that you want to limit the amount of money that they can profit from the scheme,
you don't see enemy.
They will not think about it, even though it is a very, very positive thought. They won't think about it.
Yeah, you're actually right. You understand? You know what I like these discussions is that you get to understand your view on so many things, government, finance, the country as a whole, and all of that. Now, one good thing about these things is that you must not even necessarily implement it at the national level. Tomorrow, Farida can be a local government chairman. She can be a district head. She can be a state governor. She can start from there. You understand? You implement it in your state. Watch the progress. Now, before you know it, you can have another good person. Of course, you can't tell me everybody is corrupt. There are some people that still have conscience and they still fear God. So another person, a God-fearing governor, can in another state can look at you and say, Farida, this thing you did, your people are happy with it. How did you do it? 2 states. Before you know, 3 states have implemented it. 4 states have implemented it. Imagine about 20 states implementing it. At that point in time, I'm telling you, the federal government will start they'll start paying attention to something like that. And mind you, you are the leaders of tomorrow. Unless some of you, I know, maybe you two, you have planned to be like the present leader. They say, shey they chop their money, make my time reach. In fact, the money I go chop, it go tear my pockets. Okay, go on, Michael.
I completely agree with everything that you have said. There's no negative thoughts you just mentioned. But personally, left to me, I would rather target the private sector and look for grant opportunities than wait for the government that I'm very, very sure about that. Before this thing will even work out. For don't grow white baby. So personally, I don't know about others, but personally, I'd rather target private sector, private investment, and maybe venture capitalists and grants, people that offer grants.
Awesome. I think Farida wants to counter it. He's Tech. Okay, go on, go on. Anybody
It's
want
not
to say?
necessarily a counter, to be honest. It's more like let's say a gradual process. Let's take, for example, this employer-employee relationship that I mentioned. If let's say private organizations start using smart contracts to pay their employers, right? And sorry, their employees. Let's say 1, 2 companies, you share it 3, 4, 5, 6. Big companies start using it. Before you know it, it's going to become like a very popular thing, and like it can get pushed in the like in not just in the private sector but in the public sector as well. So it's like, as you mentioned, it's a gradual process, but it can also like you might start it initially as like targeting the private sector alone, but maybe gradually, if it's going good, there's positive feedback, everything is going fine, it can also develop, become better, and meet the public audience as well. So it's all part of the process, I can say.
Awesome. Awesome. John, go
Sorry,
on.
can I
Okay,
comment?
go on, please. Olorun, go on.
I'm listening to it's an interesting conversation, really. But what people don't, what we actually see about both the private and the public sector is we see that the private sector is actually more easier for it to penetrate, but actually that's not the case. You see all these capital venturists, all these guys that have actually built their platforms into the private sector to actually get their daily bread from there will fight you to that nail when you're bringing something that threatens that. You see, in the government, all you just need to do is sell the idea to them. And if they buy into that idea, it's more easier for you to actually onboard them into the smart contract of a thing. All you just need to do is have someone that has the initiative, that understands what you're saying, and then a policy can be made. All you need in the government and in the public sector is just one single policy. But in the private sector, you will fight a battle that even let's take Dangote for example now. When he goes into the oil and gas sector, and the man has lost weight. If you check his picture the last 2 years and currently now, you will see that he has lost weight. And why is because he's fighting. Some people are fighting him. For a billionaire to come on national television and cry, then you know that the private sector is not a child's play.
Yes. Let me even add to what you said, right? I love what you said. Let me even add to it. Now, mind you, even if you are the owner or founder of your private corporation organization, do you know you still have to fight investors? Now, you be founder, but you go still fight investors. And that's why if you check, I don't know if those of you that know about DeepSeek, I think recently some investors reached out to them that they want to invest into DeepSeek. They declined. They told the investors that for now, they are okay. The money they are getting from, DeepSeek is not their main product. Their main product is all those stock market and the rest, all those forex, where they use bots to trade and all of that. So they are making some hell lot of profit. So they say for now, the profit they are making from their mother company is enough to finance DeepSeek and all of that they don't want any investor. Now, why do you think they did that? It's because by the time investors start investing in your product, they will start dictating which way you should go. They'll start dictating, some of them will even start dictating the amount of profit you are supposed to start making. And as a result of that, before you know, you start your subscription, you start increasing it and all of that. You understand? So that is just one issue with investors, which of course you find in the private sector and all of that. So thank you for that. I'm loving this class. I'm loving this class. Please go on. I think Michael was okay. Joel, go on.
With regards to the investors and private sector, it doesn't still compare to the public sector or like to the government. Okay, like for example, I'll take my school. So I was my supervisor one day, and we're talking about some processes that they have to automate, some kind of things that student can do that are supposed to automate it. So there's like this one that we talked about, a statement of result processing system where people can just get their statement of result. And I said, sir, why can't this thing be done? It's not like it's really difficult. And it's like, you can't achieve this aim because now the top people in the school, feel like, so you that is just here, you want to bring your own opportunity and come and outshine us. They will carry you, meet to you did the meeting, everybody will be nodding head. But this data to be rejected. If not even collect, like somebody might just take the idea, give the contract to someone outside, and then they just do something else and bring it to the school. So you see, like they don't fully support it. If it's going to be extremely positive, it will not be accepted. You get, even if it's a step, even if it's a process, but it's just the reality of how things work here. Sometimes even people that are serving, some of them wish and hope that they can even work in private institutions so that they get paid to some extent compared to somebody that is working in the public sector and then is not treated right. You get, so that value for what you have or what you are bringing is not entirely when you are moving into the public sector like that. Just my opinion, by the way.
Beautiful. Okay, Jetro wants to say something.
Yes, sir. I know it is very important for us to look at industries or facets that would actually adopt blockchain technology or smart contracts and how they can affect our daily life. But I want us to shift our focus a bit on what is actually the technology all about so that we can be people who will provide solutions to problems. Why am I saying this? Like the technology is still emerging. We have a lot to research on. We have a lot to build on. So we should focus on these stuffs because I know there will be a time that technology will reach a limit that every facet of your life will go back to blockchain. And now, when we concentrate to build good products, since we have these ideas, by that time, they will be the one, both public, private sectors, they will be the one looking for you or looking for this type of products that suit what they are doing. So let us just do our best as developers and people who are in the Web3 space to actually bring good ideas and good products on chain. There will be a time that I know and I am confident with the way technology is going, there will be a time that they would actually look for us and then we will do business with them.
Okay. I love this. Now, why I love Jetro's take on it, right? Do you know among us here, I'm sure that there are those that are in the educational space and they venturing into blockchain. It's not as if they want to leave education entirely. I'm pretty sure that there are those in the health space right here with us, right? So if you look at all of us, we are coming from a particular space. So ours is to look at the possibility of blockchain, how it can help in that space, the implementation and all of that. There will be a time, just like what Jethro said, where you might be opportune to be a major stakeholder in your own space. In such a way, you must have trained people that once you bring this particular suggestion, they want to pick it up and work on it. That will now be the perfect time for you to implement. I think I went to Diko Hospital, the one in Kaduna, and I was surprised. Everything they were handling it electronically. If they tell you go to so ward, maybe you go, the doctor examine you, then they need to carry out some tests. He must have sent on his computer, he must have sent your name and everything, the test they need to run and all of that. He must have sent it to them electronically. You don't need to be carrying one file around, say, what is your name? You give them the file. No. So whether you like it or not, some people must have fought it. Now, why would they fight it? Because they know that, okay, before, if you come, you have to do this, you have to do that. Now you no longer need to do that. Why? Because some of these things are being done electronically. But yet, look at them. And then you can still go to some government hospitals and still yet, you find out that they are still using paper and the rest. You understand? So if you look at it, there's a possibility that the person that stood until they implemented that thing will likely be somebody that has had it in mind since. So probably an opportunity came and then he pushed for it. And look at it, they're enjoying it today. All right, because they no longer need to waste money to go and be printing paper, printing file, and all of that. You understand? It saves cost, it saves time, it even saves record. Because imagine you keeping record, maybe you normally have every day, you normally have like up to 1,000 people coming to the hospital. Maybe in a month you have up to like 10,000. All right. So imagine managing records of like 10,000 people offline. It's not easy. You understand? But electronically now, just search papa name, age, Q. Somebody's record is out. So Michael, please go on. I think we'll soon be done. By 11:50, we'll be done with our discussion.
I just wanted to add to what you just said concerning the records. So everyone, I want to assume everyone here, even though I don't know, we went to universities and we graduated. So at the point of our final year, we were required to do our final year project. So you know how strenuous it is going up and down, printing papers here and there. At the end of the day, after you finish your project, what did they do to it? They pack everything and put in a particular room. Eventually, when the room starts getting filled up, they throw out older ones.
Yes.
They throw it away.
Yes. In fact, okay, Michael is still speaking. Am I the only one not hearing him? Wow. Hello. Is the network from on end?
I cannot hear you too.
Okay. I think it's from Michael. Michael, we don't know. Seems your network.
But I have something to say. Let me just say something.
You can go on before Michael kicks off.
Let me just put it in the health center. Like normal, when you come to cyber security, that kind of thing, they'll tell you that if you can access someone's account through other means, you can access it through his medical reports, whereby you can, when a medical report is being stated, it can be placed online and in the Web2 space, where like in the cybersecurity, they have ports you can open. Like when the hospital port is open, you can access the patient. So a port is open, you can access the patient's information. So one of the things smart contracts can do is that when it's being implemented, it can only be known by the patient and the health worker. It cannot be known generally to the public.
You are right. Absolutely right. So, Michael, is your network back? Thank you for that tech expression. Michael, is your network back? Okay, please go on. Arewa Tech.
Good morning, everybody.
Good morning.
Sorry, this is my first time here out of doing something else. Something always very bad. This smart contract.
I think we can barely hear you.
Can you be more audible?
Oh, okay, sorry, let me get my headset. Well done. Am I audible now, please?
Yes, it's better now.
Okay. I'm talking about the smart contract. How do we get to implement it to like this supermarket, right? I don't really know how it works. You understand? But I was thinking implementing it in the goods in the supermarket. How do we intertwine the both of them? As in, how do we implement it in there? Like I said, this is my first class, and I don't really know what the smart contract is. Yeah.
Okay, so actually, the question you asked, the implementation, that will come in subsequent class. So majorly, this class is just to, foundation is very important once you are looking at something. So this is just like a foundation class. Know what it is, know what is being used for. But for the implementation, you people still do it after you must have learned your first smart contract, how to write your first smart contract. And I will advise you, we had a lot of discussions today concerning possible solutions to problem, products, services. So I will advise you guys to go back home, right? Sorry, I know literally some of you are at home, but it's just a literal language. To go back home and then, look at some of these projects, put it at the back of your mind, start thinking of the implementation, because you guys work on real projects. All right, you guys work on real projects once you start writing smart contract, so that you guys will start looking at how can you write some of these the smart contracts for some of these project and products that you actually talked about, or see a possibility of smart contracts being used to make things easier or things faster or better. So I don't know. I'll be waiting for you guys then once you start your practical work. So we'll see how far. So thank you everybody. It is 11:50. It's so nice to be with you guys, and I'm really happy, right? For today's class. So we'll meet on Thursday, and after Thursday, probably Dev Hour Saturday. All right. I promise you guys one thing, elliptical something, where we look at the mathematics behind private and public key, how public key is derived from private key and the rest. All right. So please, somebody's raising up his hand. Is it George? Sir George?
All right. Good afternoon, everyone, and thank you very much, Sir Gideon. So I just want to pass this information so that everybody should get it clearly. So next week we'll be having uh, Martins, that's one of the in-house mentor, and we'll also be having the Xeon section. Though we've not concluded on the particular date, we are still in communication with the Xeon guys to get the exact date, but information will be passed across. So I just want everybody to prepare, or a lot of preparation is needed, because it's going to soon get a bit technical, or very technical rather. We would soon start writing codes and so on. So please prepare towards that. And though I don't know, Sir Gideon didn't mention much about the opportunities in the Web3 ecosystem, but I assure you that there is a whole lot of opportunities. So it's really a good shot for you to give and also add value to yourself. Just like currently now we have two hackathons that is ongoing. So if you're like already very proficient in any of these languages now, you could be able to participate. We have that of the Xeon ecosystem, of which the price pool is up to $2K. We also have that from the Edu chain, of which they have up to $250,000 price pool. This I was on the meeting with them when they were talking about the inbuilt coming up in Kaduna and so on, like that. They have so much in stake. So the opportunities is so much. And just like today class, very, very awesome class. I really enjoyed every bit of it. And we could see that there are ideas that are coming up and areas which you could implement it. These are hackathons ideas. These are stuff that you could build and you could turn into real project and real businesses. I think. So let's just get ready, because it's going to get a bit intense. If you are missing classes, try to always follow up with the recordings and the sub mentors. Like we have Venus on the call, so ensure that you also follow up with your sub mentors, especially when you start writing code. Don't just be on your own, because like one of the things we had during the last boot camp, that was the Web2 boot camp. At some point, some people were lost in the boot camp, and we don't want that to happen this time around. That's why we are trying to put structures in place so that you should not get lost. So ensure that you do your own work, follow up with materials, do assessment, and engage the sub mentors. So that's all from my end. Thank you very much, Gideon. So back to you.
All right. Thank you, Sir George. Our Ebu Oga. That video I say my Oga at the top. So to the website, say, let me confirm from Oga at the top. All right. So thank you, everybody. Honestly, like I used to be excited anytime I have class with you guys. I enjoyed every bit of it. At least I've learned a lot. Yes, and thank you for everybody that spoke. And if you have not been speaking, this is an opportunity for you to learn how to speak. Speak, oh, if you are looking for money, you have to know how to talk. You understand? I know that Mike is already on the journey of grabbing some kind of heavy business money to start business. All right. So thank you, everybody. And we'll meet on Thursday. All right. Have a great day.